Industrial Automation, ARIA 2024. As we all know, access to expert knowledge, expansion of professional network, exposure to emerging trends, and gaining a global perspective are but a few benefits that one reaps through an international conference of such stature. ARIA 2024 is jointly organized by the Manipal Institute of Technology, MAHE, Manipal University, Jaipur, in association with the University of Warwick and University of Malta. So ladies and gentlemen, for today's inaugural ceremony, we have many distinguished guests with us. We have Mr. Kishore Alva, the Executive Director in President Grade, Adani Group, as our chief guest. Dr. Vasudeva, Chairperson, IEEE Mangalore Subsection, as our guest of honor. We have a Director of MIT Manipal, Commander Dr. Anil Rana, joining us. We have Joint Director Dr. Somashekar Bhatt joining us. Manipal Academy of Higher Education is the result of the single-minded dedication of our founder, late Dr. T.M.A. Pai, a Padma Shri awardee. It was his vision to see the barren hilltop of Manipal to be metamorphosed into one of the premier centers of learning. The institutions he founded live forever to narrate a story for generations to come. The lights lit by Dr. Pai continue to glow brighter and brighter. On this auspicious occasion, it is our bound duty to pay tribute to the great visionary and pioneer of modern Manipal. I request the head of the Department of Mechanical and Industrial Engineering, Dr. Arunachal Chandavar, and Dr. Pawan Hiramach, the organizing secretary, to escort the dignitaries to pay floral tribute to Dr. T.M.A. Pai. Thank you, everyone. A good start sets the tone for a successful journey. Lighting of the lamp symbolizes a new beginning filled with knowledge and enlightenment. Following the floral tribute, may I now request all the dignitaries to inaugurate the function by lighting the lamp.
ಬ್ಲ್ಯಾಕ್ ಉಂಟಲ್ಲ ಬ್ಲ್ಯಾಕ್ ಆಗುತ್ತೆ ಕ್ಲಿಕ್ ಮಾಡಿ ಸರ್ ಕೆಳಗಿದೆ ಕ್ಲಿಕ್ ಮಾಡಿ ಟಚ್ ಮಾಡಿ Please don't hesitate to applaud.
Thank you everyone, and I request all the dignitaries to kindly occupy their seats on the dais. Before we begin the proceedings of the day, let us invoke the blessings of the Divine Almighty. I request Mr. Aditya Kadam, a third-year student of MIT Manipal, to render the invocation. And I request the audience to kindly remain seated during the invocation.
Good morning, prestigious guests. It's an honor and a privilege to have you all here. We will start by wishing upon the blessings of Ma Saraswati so that we are bestowed upon with knowledge and wisdom. Saraswati namastubhyam varde kamarupani vidyarambham karishyami siddhi bhavatu me sada. हे शारदे माँ, अज्ञानता से हमें तार दो माँ. हे शारदे माँ, अज्ञानता से हमें तार दो माँ. तू स्वर की देवी, ये संगीत तुझसे, हाथों में वीणा, ये हर गीत तुझसे. हम हैं अकेले, हम हैं अधूरे, तेरी शरण में हमें तार दो माँ. हे शारदे माँ, अज्ञानता से हमें तार दो माँ. मुनियों ने समझी, गुणियों ने जानी, वेदों की भाषा, पुराणों की वाणी. हम भी तो समझे, हम भी तो जाने, विद्या का हमको अधिकार दो माँ. हे शारदे माँ, अज्ञानता से हमें तार दो माँ. Thank you.
Thank you, Aditya, for that melodious rendition. I now invite Dr. Pavan Hiramat, the Organizing Secretary of ARIA 2024, to formally welcome the august gathering. Over to you, Dr. Pavan.
Very good morning, everyone. It's my privilege and pleasure to extend a warm welcome to all of you who have gathered here for the inaugural ceremony of IEEE ARIA 2024 conference. At the outset, let me extend a special welcome to our chief guest, Mr. Kishore Alwa, President and Executive Director, Adani Group India. Sir, we are deeply honored by your presence and look forward for your inspiring words. I am equally delighted to welcome our distinguished guest of honor, Dr. Vasudeva, Chair IEEE Mangalore Subsection, Mangalore, India. I am delighted to welcome the distinguished guest of honor, Dr. Somshekar Bhatt, Joint Director, MIT Manipal, for your presence. I would also like to extend warm welcome to Commander Dr. Anil Rana, Director, MIT Manipal, who is presiding over today's ceremony. Sir, actually your visionary leadership continues to inspire us in all the endeavors. I also take this opportunity to warmly welcome Dr. Arunachal Chandavara, the Head of the Department of Mechanical and Industrial Engineering. Sir, your steadfast support and guidance have been backbone to our efforts. Thanks for all the supports you have given us here. I extend my gracious welcome to our keynote speakers, Dr. Mayuk Das, Senior Research Scientist, M365 Research Group, Microsoft, and Dr. Richard Sharma, JK Lakshmipant University, Jaipur. Your presence is truly inspiring and hope all the audience will make use of it. Thank you. I also noticed the presence of Mr. Yash Parmar from Rimtex Industries, who is a panel member for today's discussion, and Dr. S.S. Sharma, our ex-HOD, and this conference was initiated during his tenure. I extend my warm welcome to you, sir. A heartfelt welcome to the esteemed co-organizers, conveners of IEEE ARIA 2024 from Manipal University, Jaipur, Dr. Princy Randhawa, Dr. K.K. Pandey, Dr. Girish Kumar Kaushik. Your collaboration and dedication are instrumental to the success of this conference. I would also like to extend my greetings to my dear friends, colleagues, conveners, Professor Nitesh Naik, Suhas Kaushik, along with all the committee members of ARIA 2024. Actually, your tireless efforts and commitment have brought us to this significant milestone. A heartfelt special welcome to all the faculty members, AV team of MAHE, media partners, especially from U Channel Udupi, the students, my dear colleagues and research scholars whose valuable contribution has been instrumental in making this conference a success. Last but certainly not at all least, a special welcome to all the participants of ARIA 2024. Your enthusiasm and curiosity are what actually drives such initiatives forward. This conference would not have been possible without your active involvement. It is a privilege to host you here at Manipal Institute of Technology, Manipal. Your presence not only adds immense value to this event, but also elevates the stature to a truly global level. Let us make this conference engaging, insightful and memorable as we delve into the advancements in augmented reality, intelligent system and industrial automation. Thank you once again. I welcome you all who have gathered here for this inaugural ceremony.
Thank you, Dr. Pawan. A warm welcome to you too. I now invite Dr. Princy Randhawa, convener of ARIA 2024, to present the overview of the conference.
Good morning, everyone. It's a great honor and privilege for me to welcome all of you for our first IEEE International Conference on Augmented Reality, Intelligent System and Industrial Automation, ARIA 2024. I'm pleased to present an overview of this landmark event, which brings together a global community to discuss advancements in immersive technologies, intelligent systems, robotics, and next-generation automation. ARIA 2024 represents a collaborative effort to bring together experts, researchers, and industry leaders from across the world. This conference focuses on innovation, collaboration, and applications of emerging technologies to address real-world challenges and drive progress. The conference has 5 tracks and each designed to showcase the latest developments in technology. Robotics and industrial automation, which addresses the advancement in robotics and their integration in smart manufacturing and industrial system. Industry 4.0 and 5.0 explores IoT, cyber-physical system, and human-centric automation for smarter factories. Bioengineering and medical technologies features innovation in biotechnology, healthcare, medical robotics, and AI applications in diagnostic and treatments. Artificial intelligence and machine learning highlights the progress in AI-driven solutions, deep learning, and machine learning applications. And last, communication and networking, which examine the next generation communication protocols, IoT networks, and the transformations of industries through digital connectivity. If we talk about the conference statistics, we received a remarkable number of papers for our first conference with 675 submissions from researchers across the globe. So after a rigorous peer review process, 230 high-quality papers were selected, which showcase the dedication and expertise of the global research community. We have participants from diverse countries, including India, USA, UK, Iran, Malta, Bangladesh, Sri Lanka, and many more. This conference adopts a hybrid format with 60 offline participants and 170 participants delivering and discussing their research in online mode. The event includes insightful 10 keynote speeches by distinguished experts and 40 invited speakers from industry and academia. I'm sure the panel discussion on various domains on applications of AI will provide all the delegates with an insightful experience. A conference of this scale would not have been possible without the support of our sponsors and contributors. So I extend my heartfelt gratitude to our technical sponsors, IEEE Global, IEEE Bangalore section, and IEEE Bangalore section for their invaluable guidance and expertise. I also thank to our event sponsors, Rimtex Industries, Geek for Geeks, State Bank of India, and Pratham Group. Special acknowledgement goes to Smarika for crafting the beautiful mementos and dot printing solutions for their creative visual designs, and also the Chef on Wheels for the healthy and tasty food they serve us for this conference. So as we gather here today, I am reminded of the words of Henry Ford. Coming together is a beginning, keeping together is a progress, working together is success. So this conference is a collaborative effort to discover better solutions, innovate and develop technologies that address real-world challenges and build a brighter future. So I encourage each one of you to engage actively, share your ideas and forge meaningful connections. So let AREA 2024 be remembered not only as the first but also as a significant step towards driving innovation and making a lasting impact. So before I conclude, I want you to leave a bit of suspense. During the validatory session, we will unveil about the second edition of the conference. So stay tuned. So it will be something worth looking forward to. So thank you everyone for being a part of this event. Together, let us make this AREA 2024 an inspiring and transforming experience. Thank you.
Thank you, Dr. Princy, for presenting the bird's eye view of the conference. May I now request Dr. Arunachal Chandawar, the head of the Department of Mechanical and Industrial Engineering, to present an overview of the host department to the August gathering. Over to you, sir.
Good morning. So, respected dignitaries on the dais, off the dais, dear participants, my dear colleagues, and MAHE, as well as MIT officials and research scholars. So, it's my privilege to represent department and to present the overview. This is the biggest department, MIT, as well as second oldest department. Yes, so we have a vision which has three major verticals, that is research, innovation and teamwork. So even the mission is aligned with these three verticals, and that's what, because as you know, nowadays apart from the regular academic activities, research and also the kind of industry collaboration lead to innovation. These all components are very much essential, and that's what we really targeting these years, so as to enrich the academic curriculum. So in fact, the BTech Mechanical Engineering program started way back 1960. So we have more than 6 decades of our expertise in this particular program. And that followed by industrial and production engineering that we started during 1976, and now it is renamed as industrial engineering. So, and this year itself, I am glad to share you that we also started BTech Dual Degree program with the Deakin University, Australia. It is 2+2 program. Yeah, apart from this BTech programs, we also offering 3 MTech programs: computer-aided analysis and design, then manufacturing technology and automation, as well as thermal science and energy systems. Then both part-time and full-time PhD programs. And as you know, nowadays, the Industry Connect, that activity is very important. And as a part of that, we also started a work integrated learning program. And right now we are offering a diploma in mechanical engineering for working professionals of CIPLA. Yes, coming to the faculty strength, that's what I said. We are the biggest department in MIT. We have 86 faculty, and you can just check the statistics. We have more than 15 faculty having 30 plus years experience, and so that's the statistics we have. Yes, coming to the, apart from the regular, on-roll employees, so we also have on special role professor of practice, then international faculty, as well as adjunct faculty. That number is visible. So this is to enrich the regular academic as well as the Industry Connect program. Yes, now, as far as qualifications concerned, more than 68 faculty members, they are doctorates, and another 13 they are pursuing MTech, and we have few very senior professors. They are having the qualification of MTech. Yes, so since we are close to 90 faculty, so recently we made 4 different streams so that every stream can get benefited, and accordingly we made it as manufacturing materials engineering stream, then industrial engineering, thermal engineering, and design engineering. So all this 86 faculty has been divided into these 4 groups, and they have their own entity to let it be regarding the budget allocation, lab development, curriculum development, everything. So we have respective area heads. So together they take care of both BTech as well as MTech, also the PhD program. Yes, coming to the different laboratories, again we classified into 4 divisions, that is thermal engineering laboratory. As you can see, we have 5 main laboratories, which includes both UG, PG as well as research activities. Yeah, there are a few just images you can check, and during free time definitely you can visit various our laboratory facilities. So we have state-of-art UG CAD lab. Then for first year students we have engineering graphics lab. Then industrial engineering laboratories. Yes, yesterday you had the workshop, and that is run through Intel Unnati Artificial Intelligence and Data Centric Lab. This is the one, the very important or the significant activities what it is doing under industrial engineering stream, and we also have computer aided industrial engineering lab as well as work systems lab. Yes, so hope all of you enjoyed this facility yesterday during the pre-conference workshop. Yes, so we have very good machine shop facilities, so that most of our requirement kind of experimental setup or research equipment, so we build in-house by taking help of a lot of these machines. It starts from conventional lathe to CNC bay, including 3D printer and wire EDM machines and state-of-the-art other welding machines. Okay, so CAD lab separately we have for research, postgraduate as well as undergraduate category. So we have plenty of softwares because that is has been listed. That's why I said during free time, please visit all these facilities and definitely you will enjoy. Yeah, these are the other laboratories coming under MTech thermal program. And we have under design stream the state-of-the-art facility like scratch tester, rheometer, then lubricity tester, air bearing tester, then the faulty automatic, fully automatic grinding machine, then digital Vickers hardness tester. So like this, there's a big list. And also we have a lot of equipments under central laboratory facility. That is Central Analytical Instrumentation Facility. So we have that. Yeah, under that also lot of equipments definitely as listed. Yes, under design stream, so I just mentioned a few the research areas, which includes design of permanent magnetic bearing, then neural network in condition monitoring, multipad and multi-lobe bearings, as well as deep learning in prediction of tool wear surface roughness. So similarly, under manufacturing stream, we have machining optimization of metals, like that, thermomechanical analysis of metals and alloys, application of statistical tools for machining optimization. And similarly, under thermal stream, design and analysis of heat exchangers, solar thermal system, design and analysis, microfluidics, even biolubricants preparation and characterization, evaporative cooling, cooling tower performance analysis, and we have a very kind of dedicated group towards the CFD analysis. Yes, coming to the research performance, our department publication in the last 5 years, it is close to 1,000, and student wise it is 250 plus. These all are in reputed international journals. And patents also, so as the statistic says that we have a lot of patents through our research scholars, faculty, even at the UG level also we have such activities. Even the grant details are mentioned. So though it's a private university, still we are getting very good number of grants from even industry and central government funding agencies. So these are the few ongoing grant details from DRDO, then DST, Wipro, and Ingersoll Rand, that's a consultancy project. So recently we started that project. And as a part of our regular academic and research activities, we have a lot of MOUs. So as you can see, right from CSIR, Intel, Rimtex, Minar, Everest Blowers, then many group of industries, Signet, Wipro, Forbes Marshall, then IIT Jammu, as well as Ingersoll Rand Technologies. And apart from this MOU, we also have industry-sponsored courses for our UG program. For example, L&T EduTech, they are offering electrical vehicle technology courses, and similarly Volvo, also they are offering courses, and shortly we are also planning to have open elective course from Forbes Marshall, that is steam engineering. This allows to enjoy the industry, the kind of culture or the kind of curriculum our students can enjoy. Yeah, and recently our students, their 8th semester project, so they won the first and second prize offered by Forbes Marshall Pune. So they received first as well as second prize, the two undergraduate, that's 8th semester in-house projects. And these are the there's a brief list of our internship and recruiters for both BTech and MTech program. So before concluding the session, I'll show just 2 video clips, one related to the MTech laboratories. And some of these setups we built in lab itself. Yeah, so that is the overview of our department. Thank you.
Thank you, sir, for detailing the strengths and collaborative opportunities at the department. Thank you once again. Ladies and gentlemen, we have with us an esteemed professional with over 26 years of experience in leadership roles across multinational organizations. Currently, he serves as the Executive Director in President grade at the Adani Group, overseeing corporate affairs for UPCL, Mangalore Airport, Udupi City Gas Distribution, and other Adani ventures in Karnataka. He has held pivotal positions in US IBC, Chevron, China Light and Power, and Cogentrix Energy. He also served as President of the Bangalore Chamber of Industries and Commerce in 2018-19, steering it to a remarkable achievements, including a record of 150 events and fostering industry growth in Karnataka. A distinguished alumnus of National Public School, Bangalore, and St. Aloysius College, Mangaluru. He is a sports enthusiast who continues to contribute to education as a board member at St. Aloysius College and Mangalore University. His dedication and contributions to industrial development in Karnataka have earned him several accolades, including the prestigious Parimala Prashasti. With this brief introduction, ladies and gentlemen, I request Mr. Kishore Alva, our chief guest for the function, to address the gathering.
Respected Dr. Vasudeva, Chair IEEE, Dr. Vinod Thomas, I don't think he's present, Registrar Evaluation, Commandant Dr. Anil Rana, Director, MIT Manipal, HOD, Organizing Secretary, Professors, dear students, faculty members, international delegates, one and all. It's a great privilege to be in the University of Manipal, which I consider it as the highest seat of learning in the state of Karnataka or maybe in India. Well, I was the president of the All College Students Union long back, and I have a 3 decades relationship with the Manipal Institute, starting from Ramdas Pai and to the Pai family. In fact, it's a great privilege to be here. And good morning, everyone, again. It's an immense honor and privilege to be the guest for this international conference on augmented reality, intelligent systems and industrial automation 2024, organized by this institute, great institute. This gathering of brilliant minds and innovative thinkers is a testament to the incredible strides being made in these transformative fields. I extend my heartfelt congratulations to the IEEE and the organizing committee for orchestrating this important event, which brings together some of the most innovative minds from across the globe. The convergence of augmented reality, intelligent systems, and the industrial automation represents a paradigm shift in how we interact with technology, solve complex challenges, and drive industries forward. These technologies are no longer confined to academic research. They are reshaping healthcare, manufacturing, education, entertainment, and countless other sections, making the world more connected, efficient, and innovative. Augmented reality, AR, is unlocking unprecedented ways to blend the physical and digital worlds. From immense learning experience to real-time assistance in industrial maintenance, AR is enhancing productivity, creativity, and collaboration across disciplines. AR is revolutionizing how we perceive and interact with the world around us. Intelligent systems powered by advancements in artificial intelligence and machine learning are enabling machines to think, learn, and act. These systems are revolutionizing industries by optimizing decision-making, enhancing safety, and addressing challenges that were once deemed insurmountable. Industrial automation is the backbone of modern technology, improving efficiency, precision, and sustainability. With the integration of intelligent systems and AR, automation is achieving new heights. From predictive maintenance to smart factories that are more responsive to dynamic market demands. The convergence of these technologies is creating a new frontier of innovation. For instance, augmented reality tools powered by intelligent systems are enabling technicians to perform maintenance tasks more effectively. Similarly, industrial automation integrated with AI-driven insights is enhancing productivity while minimizing waste, aligning with global sustainability goals. As we embark on discussions and explore the groundbreaking research presented at this conference, let us remember the ethical responsibilities and societal implications of these technologies. Our innovations must aim not only to advance industries but also to improve lives, foster inclusion, and ensure environmental sustainability. Dear researchers, industry leaders, and students here today, your work is shaping the future. Every paper, project, and idea shared at this conference has the potential to inspire new directions and catalyze further innovation. Collaboration, interdisciplinary approaches, and a commitment to excellence will be the keys to the unlocking the full potential of these transformative technologies. I congratulate the IEEE and the organizing committee for creating this invaluable platform for knowledge exchange and collaboration. Your efforts in bringing together such a diverse and talented group of individuals are commendable and vital for the progress of science and technology. Dear friends, this conference serves as a crucial platform for researchers, practitioners, and industry leaders to share the latest advancements, exchange ideas, and forge collaborations. The research and projects presented here will not only address today's challenges, but also lay the groundwork for the future. In conclusion, I encourage everyone to make the most of this conference to engage in meaningful discussions, foster new partnerships, and explore bold ideas. Let this event serve as a catalyst for innovation and a beacon of progress as we collectively work towards a smarter, more connected, and a sustainable future. And in fact, I had a small discussion with Commander Dr. Anil Rana. I invite you all to one of the finest thermal plants, which is about 20 kilometers from Kudpi, at the place called Padubidri. Adani is having one of the biggest projects over here in Karnataka. It's a 1,200 megawatts thermal power station, one of the finest one, with imported coal. And also we have about 27 solar locations in about 28 taluks in Karnataka, which is one of the biggest of the Adani facilities after Rajasthan. So we produce about 750 megawatts. So we cater to about about five districts. territories of Karnataka. And we are also into logistics, we are into cement manufacturing, ACC Ambuja, and then Penna, and then Orient, and Sangvi also. And we have the Hudpi gas pipeline, which connects from the border of Mulki to Baindur. And we are also into the aero and the defense technology in the state of Karnataka, and also we have taken over 3 years back the Mangalore International Airport, which is going on in a big, in a bigger phase. So in conclusion, I encourage everyone to make the most of this conference, to engage in meaningful discussions, again, foster new partnerships, explore bold ideas. Let this event serve a catalyst for innovation and beacon of progress again. I congratulate the organizing team of the IRA 2024 and wish the conference great success. May this event inspire groundbreaking ideas and collaborations which will shape the world of generations to come. Thank you, and I wish the conference great success. Jai Hind and Jai Karnataka. Thanks.
Thank you, sir, for your words of appreciation and emphasizing the importance of AR, AI, ML, which is definitely aligning with the theme of the conference. Thank you once again, sir, for addressing the gathering. Ladies and gentlemen, we now move towards another important activity for the day, the release of the conference souvenir. I request our chief guest to kindly release the conference souvenir, and I request all the dignitaries on dais to kindly join and do the honors. I also request the conference conveners to join for a photograph of the release. Thank you, everyone. Ladies and gentlemen, we have another eminent personality on the dais, a distinguished academic and researcher, currently serving as professor in the Department of ISE at NMAIT NITE, a doctorate in graph theory and applications from NITK Surathkal, whose thesis received the Best Thesis Award in Computer Science by Vice Government of Karnataka. He has authored over 30 research papers and presented at prestigious conferences worldwide, an accomplished research supervisor who has successfully mentored 4 PhD scholars and is currently guiding 3 more. He has held key positions such as chair of the IEEE Mangalore subsection, served as a member of various committees such as the VTU and Goa University. His accolades include the IEEE Outstanding Service Award, Teaching Excellence Award, and recognition as the regional mentor for Atal Tinkering Labs by NITI Aayog. With this brief introduction, I request Dr. Vasudeva, the guest of honor for today's function, to kindly address the gathering. Please welcome him on stage.
Eldrigo Namaskara, dignitaries on and off the dais. This is my 3rd visit for IEEE conferences this year. Of course, out of 6 conferences that we had in this IEEE Mangalore subsection region, this is 3rd time happening in MIT Manipal. That's a great thing to note, because I always feel that conferences are the platform to connect, collaborate, and communicate. More open access it is, because researchers are presented before the audience openly, because in journals, of course, it is very selective. as far as this conference is concerned, I had one role. When the application was withheld at section level, I asked Bangalore section people, if not MIT, then which institution you will be selecting? And within a week we got the approval. Of course, because in Bangalore subsection what we feel is we need the conferences which are model to others, because we need to have benchmark conferences so that if other institutions, tier 2 or tier 3 institutions want to organize conferences, we want to show a model. This is how you are supposed to do. I think MIT is doing great. Even ICT department last month they conducted and they uploaded the proceedings within 3 weeks. And last week EC department organized one more, and this week you are organizing. I think next year 3 more conferences. Already I have received the MOU from IEEE to sign. So that is a great thing, because I always feel that conferences are the real avenues for the researcher to collaborate, communicate and all. But of course we remember pre-COVID days. Let me give the example of NITK. We used to have the inauguration of conferences in Silver Jubilee Auditorium, which used to accommodate about 1,000 people. Now I think COVID has gone, but its effect has not gone. People are preferring online, and in online also they will prefer to come as in Yakshagana. They come and go. They present, usually the Rakasa rules. They come for war and killed by the demon, Vishnu or Devi, something like that, and they will abscond. So that is how it happens, and that is not the way it has to be. But I feel that the physical mode should come again, and we have to collaborate, we have to get the people, we have to meet the people, and we have to see the people. Of course, a lot of facilities have been shown by the mechanical engineering department. Unless you come here and see those things, I think we can enjoy it only in video. So what is the use of that? So it should happen in physical mode, so that much collaboration should happen. And I am very much happy to collaborate with MIT. Of course, I am collaborating with conferences, and I am the part of DAC, and also recently I have been appointed as co-supervisor for 2 students doing PhD. So I think my collaboration will continue with MIT. And it's a great to know, great to be here. I wish the conference every success, and let it explore a lot of things. Of course, intelligent system is one of my area of expertise, but let me not show my expertise here, because 10 more speeches are there, invited talks are there, keynote addresses are there, and 230 papers are going to be presented. Too much is too bad. So I wish you all the best. Thank you.
Thank you very much, sir, for all the support extended towards MIT in general and ARIA 2024 in particular. We would definitely like to continue the partnership with IEEE. Thank you for the best wishes. Thank you very much. Ladies and gentlemen, we also have with us the Joint Director of MIT Manipal, Dr. Somshekhar Bhatt. He is from the background of Electronics and Communication Engineering. He was the head of the Department of Electronics and Communication Engineering, and then he was the head of the Education Technology Cell at MIT. He is a doctorate from IIT Madras, a professor and a PhD guide who has guided numerous candidates, who has published in many revered international journals, conferences worldwide, and is now heading as the Joint Director of the Institute. With this brief introduction, may I request him to address the gathering. Sir.
Organizers have pushed me to swim without informing that I have to be swimming in the pool. So Anyhow, I have a role tomorrow also in the valedictory program, so whatever I wish to speak, I will keep it for that. What is important is, as IEEE chair said, conferences are providing an opportunity for us to interact, network, and that can happen when it is in physical mode. So all those who have preferred online mode, next time at least make sure that physically visit here, see our facility. Probably myself and director, we were talking, the facility is what was presented by the HOD. Should it be presented like that? But now I feel that if majority of the people are attending online, and if they are not getting an opportunity to see the facilities what we have, then probably that networking, interaction, collaborative research, that may not happen. So that way, if more and more people attend in online mode, so probably the only way we can showcase our facility is through a presentation like this. So it may happen that we may feel that there is no place for that here, but it may become a trend in future conferences when more and more people attend in online. But I see physics faculty, I see electrical faculty, I see computer science faculty, many faculty from other departments. So this is more and more important because today a research can progress only when people from multi-domain come together, and this conference has provided that platform for all of you to come together and see the development that is happening in your field, how can it help for the progress of the other field. And I'm sure that with 230 presentations, more than 20 key presentations, there will be a lot of interactions, and you all will go back with enriched experience. All of you who are here physically, make sure that you go around the campus, see our facility, so that tomorrow when you go back with some idea for collaborative research with us, to send your students, if you're a faculty somewhere, undergraduate students for postgraduate program with us, postgraduate students for PhD program with us, and that can also happen. I wish the organizers all that success and all the participants an enriching experience. Wish you all the best. Thank you.
Thank you very much, sir. Ladies and gentlemen, we have with us today a commander who has been piloting this huge ship called MIT Manipal, the director of MIT, Commander Dr. Anil Rana. Let me introduce him to the gathering before I request him to present the presidential remarks. Dr. Anil Rana has served as a commander in the engineering branch of Indian Navy in various roles and has over 30 years of experience in industry and academia. He has pursued his MTech at IIT Delhi, completed his PhD in reliability engineering from IIT Bombay. Post his naval service, he served as Associate Dean Research and Professor of Mechanical Engineering at Fiji National University in Fiji Islands for 5 years, followed by Dean Academics and Professor at Symbiosis Skills and Open University, Pune. He was Dean Faculty of Manufacturing Skills at Dean Academics at BSDU Jaipur before taking over as Vice Chancellor of Oriental University, Indore. He has a long list of publications in various reputed national and international journals. With this brief introduction, sir, I request you to address the gathering.
Thank you. A very good morning to all of you. Firstly, let me apologize for my late coming in the morning. There was a morning meeting in MAHE in the university, and everybody's got a lot of energy in the morning. So the meeting that was supposed to be limited to 15 minutes got extended to almost like 25 minutes. I don't blame them, but I had a very important conference here, so I had to arrive late. So apologies for that. But at the same time, I'm very happy that I can see many experts were present. Let me start by the dignitaries of the dais. I'd like to thank Mr. Alva for taking out your time and being with us, sir. And also Dr. Vasudeva, Like he mentioned, he's already been here 3 times. I think we may have to provide an office to him next time. All the conferences that are going to rain, especially in the times in the November, December, or during the vacation, because that is the time when we generally hold conferences in large numbers, because the students are away, we are at peace, and most of the faculty members also have little free time in their hands. And also I'd like to thank firstly the department and compliment them for organizing this particular conference on a very important topic like this, and to all the representatives from various other universities from the country as well as outside the country, and the participants who have come from various places. If this is your first time in Manipal or maybe first time inside MIT, I would recommend what Joint Director just said. Please go around, visit the facility. I would ask the organizers of the conference to please arrange for that. If you have not already planned, I will help you with the logistics, because that is very important. And you require at least 2 full days to completely visit all the facilities in MIT as well as in MAHE. If I talk only about MIT, let me just tell you the numbers. We have got about 128 labs, 38 research labs, 18 centers and centers of excellence, and many more. There are some centers which have been created recently, and it is on a phased manner getting implemented. But it is worth noticing that anything which is at the forefront of the technology advancement today, you have it in MIT. So whether we talk about semiconductor fabrication facility, it's coming up. Whether we talk of analytical instruments, it's coming up. First phase already implemented, state of the art, must visit. In addition to that, there are many other centers, research centers in collaboration with the industries, where the industries have also invested, because there's a lot of mutual benefits there for the industry as well as for us. For us, it is the students who get benefited, who get an opportunity to work alongside our researchers on some very important research topics, and thereby get this valuable experience before they even graduate from here. Talking about the conference and the topic that I'm seeing, it just reminds me last 2 Times articles. I don't know if you've seen this. On Wednesday and Fridays now, Times of India, at least on the major metros, they carry a page called Times Techies. And I was surprised to read on Wednesday, there's a company called ABB, Swedish-based company, which is big time into robotics and automation. And they're talking about how generative AI is getting integrated in terms of use of AI for perception, navigation, and planning, right onto the robotics platform. You know what it means? It means that you can talk to a robot in your own language, and the robot will understand what you want it to do. It can identify unknown objects. It can navigate its own plan, how to move around using that virtual SLAM system on the complex shop floor and get the job done. Which means all those engineers who are involved in programming, coding the robot, their jobs are gone in next 5 years at least, or maybe even earlier. So there is always a need to look at what advancements are happening and how do we prepare our students for that future is very important to an education student, very important to MIT Manipal also. And that is the reason why we are very, very keen to hold conferences where we bring experts in particular chosen topics to come discuss, present their papers, give an opportunity for the researchers as well as our students also to interact with them and learn firsthand the changes that are coming and how the students can prepare themselves for the future. This is very important to us. I would also like to mention that most of you would be aware, but if you are not, let me just tell you that MIT, a constituent unit of MAHE, which is an institute of eminence, is today standing proud at number 4 position in the world, in the country ranking, NRF. In the world, it has been ranked by all 3 world ranking agencies. Why it matters is because for a very long time, whenever it came to research funding, especially from government organizations, generally it would go to the government-funded institutes. Private universities, engineering colleges were generally last in the queue. But that is changing now. Some bit of it is due to the government which is there, and they are looking at the private universities and their expertise also. But much is also coming from the new standing that the private universities are gaining, and MAHE is like standing tall right at the front. The first three in the ranking in NIRF are the government funded universities, and there are a lot many down the list, but MAHE has every year on year climbed 1 or 2 positions and reached number 4. And how it has changed things for us, we have a hub of medical devices where DST has pumped in about 12 crores, and MAHE themselves invested 12 crores, 24 crores set up just for the equipment facilities is there in the Central Analytical Instrument Facility there in MIT. We also have, you must be aware, the Center of Excellence that was announced by the Department of Education, putting 300 crores in each center. Each center was looking at AI/ML application in different areas. The one center for healthcare, second for sustainable cities, third for agriculture. So MIT along with the other institutes of MAHE came out with a consortium and applied for that grant. And today it is the only private universities which has been selected and has gone through the phase 2 process and part of the Center of Excellence. That is indeed a matter of pride, but it also shows that the government is very keenly looking at even the private universities which can break that barrier, stand tall in terms of excellence in research, and can get the grant successfully. Second, the PAIR program, which is coming up, where only the first top 25 institutes have been selected. These institutes are going to work in a hub and spoke model. We are again very proud to say that we find our name there, and we have now successfully collaborated with other spokes and are preparing our proposal. I believe the last date was 31st December, now extended to 31st Jan. Why these things I am mentioning here is because it just gets to show everybody that MIT, Manipal and MAHE are very, very closely looking at all the opportunities that are there in the country to seek grants for conducting research which has a direct impact and bearing on improving the society's living standards as well as the challenges that they're facing, and coming out with viable solutions. So every country has got its own kind of a problem, and the solution has to be indigenously manufactured or made within the country so that the solution is optimum in terms of cost and in application. Wishing this particular international conference all the very best. Happy learning to all those who are participating, and I'd like to thank all the keynote speakers who are there in the list, and some of them are very, very eminent speakers. If I find time, I'll definitely like to attend a few of those. I hope all these speeches would be recorded and would be made available to anybody else, even if they're not attending the conference. Thank you. Jai Hind.
Thank you very much, sir. Ladies and gentlemen, let us profusely thank all the dignitaries on the dais who have spent their valuable time, shared their insights, and showered their blessings on the conference. As a token of appreciation, the conference committee would like to present a token of appreciation to the dignitaries. May I request our director, Dr. Anil Rana, to kindly present a memento to our chief guest, Mr. Kishore Alva. Thank you, sir, and may I now request Dr. Somshekhar Bhatt, the Joint Director of MIT, to present the memento and do the honors for Dr. Vasudeva, our guest of honor. May I now request our HOD, Dr. Arunachal, to present a memento to our Director, Dr. Anil Rana. Sir, I request you once again to present a memento to our Joint Director. And I request Dr. Pavan Hiremat to present a memento to our HOD, Dr. Arunachal. Thank you, everyone. Ladies and gentlemen, with this we inch towards the end of the formal function. I request Dr. Girish Kaushik, faculty from Manipal University, Jaipur, and co-convener of the conference to present the formal vote of thanks. Over to you, sir.
Thank you. Vote of thanks is also the most awaited event of any conference, so we can say that. So, good morning to all present over here. I am presenting vote of thanks here. It is my privilege to stand before you today as we conclude this momentous event. On behalf of the entire organizing team, I extend my heartfelt gratitude to all those who have made this event a great success. First and foremost, I would like to express my sincere thanks to the management of Manipal Academy of Higher Education for their unwavering support and guidance. Their vision and leadership play an integral role in success of events like this. A special thanks to Dr. Ranjan Pai, Chairman of the MEMG Group, for his continuous encouragement and for being a pillar of the strength for the entire academic community. We are truly grateful for your commitment to education and innovation. Our deepest appreciation also goes to the Lieutenant General Dr. M.D. Venkatesh, Vice Chancellor of Manipal Academy of Higher Education, and Dr. N.N. Sharma, President Manipal University, Jaipur, for steering the institution towards greater heights. Your leadership is inspirational to all of us. We would also like to extend our heartfelt thanks to Dr. Narayan Sabahit, Pro Vice Chancellor, Technical, Manipal Academy of Higher Education, and Dr. Karunankar A. Kotegar, Pro President, Manipal University, Jaipur, for your vision and relentless support in driving forward technical excellence at our institution. A big thanks to you, Dr. Girdhar P. Kene, Registrar, Manipal Academy of Higher Education, Dr. Neetu Bhatnagar, Registrar, Manipal University, for his constant encouragement and for ensuring smooth coordination of all administrative matters. Our sincere thanks to Dr. Anil Rana, Director, MIT Manipal, and Dr. Kuldeep Singh Sagwan, Dean Faculty of Engineering, Manipal University, Jaipur, for being an immense source of inspiration and for your guidance in making this event a reality. We are also grateful to Dr. Som Sekhar Bhatt, Joint Director of MIT Manipal, whose effort behind the scenes has contributed to the smooth functioning of the event. A special note of thanks to Dr. Arunachala Chandavar, Head of the Department of Mechanical and Industrial Engineering, Dr. Prabhat Ranjan, Head of the Department of Mechatronics Engineering, MUJ, for your active participation and your continuous support in all academic initiatives. I would like to extend our deepest gratitude to the esteemed University of Warwick and University of Malta that have graciously partnered with us for this important initiative and knowledge sharing platform RER 2024. I would like to extend my heartfelt thanks to all the faculty and staff members for their dedication and hard work in ensuring that everything runs smoothly. Your contribution is invaluable and we appreciate your efforts immensely. I also wish to thank my fellow organizing secretaries, conveners and co-conveners for their collaboration and tireless efforts in making this event a success. Your teamwork, enthusiasm and dedication have truly made a difference. I thank Ratnakar, Ashok Rao and team who has tirelessly worked for this conference. In conclusion, I once again express my sincere thanks to everyone present here today for your participation, encouragement and support. Without each of you, this event would not have been possible. Thank you so much. Thank you, Jai Hind. Jai Bharat. Jai Bharat.
Thank you, sir. Ladies and gentlemen, nothing better than national anthem to invoke the sense of national pride and camaraderie. May I request everyone to kindly raise for the national anthem before we end the formal function.
जनगण मन अधिनायक जय है भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. So with this, we come to the end of the formal function, and I request all the dignitaries to kindly occupy the seats of the dais as we move towards the keynote address for the day. Ladies and gentlemen, there is tea served outside the auditorium. Please join us for tea, and the keynote sessions will happen after the tea break. Sorry about the confusion. I repeat, request you all to join us for tea break outside the auditorium, and once the tea break is done, we will quickly assemble back for the keynote sessions.
No, it's the same sound, but it's like the pronunciation is like
ఉన్నది మధ్యాహ్నం ముట్ట మాత్రం కీనోట్ అడ్రస్ గాండ్ మూల Kira back di kena. I work there. Maruri. Hey, Navin and Nel. Boleh. Bapak. Bapak kan yang punya. Jangan dua hari. Ini baru jadi. Bapak itu. Jangan ada, biasa ada. Ini IT business. Iya kita mandiri. Kayak bene. Jangan ada korma, rekrutan payment, laptop. Software on the lab. How we get to make one lab that way. How am I going to get there? If they want to work with my now you know to work out. I don't know. They know.
It's unfair. Talk daily. It's use it's an important go there. Dudu ಖರ್ಚು Mechanical founder staff ಎಲ್ಲ ನಾವು ಕೇರಳ ಆಯ್ನ ದಿನ ಟೀಚರ್
my old staff
21 September, first lab open, Pawan Chandra in charge.
ಅದಾಗಿ ಇದು ಮೆಕ್ಯಾನಿಕಲ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಪಕ್ಕದ ಇದೆ ಗೌರಿ
ಅದೇ ಏನು ಫೋಟೋಗ್ರಫಿ ಎಲ್ಲ ಇತ್ತು ಅಷ್ಟೇ ಅದು ಮಧ್ಯೆ ಡಾಕ್ಟರ್ ವೀಕೆಂಡ್
Life is all about choices. My choices define who I am or what I'm going to become. My choices shape my everyday experiences. So what do I experience? Far from my family, I'm getting to know what it is to be on my own. But with friends who come from across the world, I never feel I'm all alone. Of course, I dream big, so I do excel in academics, which is pretty rigorous. But don't take me for a nerd. I do have times when I'm absolutely frivolous. I create, I debate, I work hard, I innovate, and it doesn't matter even if I'm working late. She's my best friend forever, but I fight with my roommate. Because we do make mistakes, but with a warm hug or a big smile, we start again with a clean slate. There are so many things to learn now, so many things to do, and so much more I can become. Just out of the blue. I experience freedom here. I experience confidence. I experience opportunity. And I experience awesomeness. So what do I experience?
ಅಯ್ಯಪ್ಪ ನಗರ ಗಣೇಶ್ ನಗರ ಅಂತ ಅಂದ ಅವು ಶಾಲೆ ಗೌರ್ಮೆಂಟ್ ಶಾಲೆ ಅವು ಇಂತ ಅಲ್ಪ ಮಲ್ಲ ಹೋಟೆಲ್ ಬಿಲಿಚಂದಿ ಸ್ಥಾನಕ್ಕೆ ದುಂಪೋದು ನನಗೆ ರೋಡ್
moves us out of our comfort zone, drives us to challenge status quo, makes us think, what else can we do? How else can we solve? What else can we impact to make the world a better place? Are the change makers, the disruptors, the ones with the grit to challenge the naysayers. The legacy inspired by life guides our present to shape the future. It gives us the confidence to go out and change. We are the believers who dream big thinkers without collective passion to make our dent in the world and change it for the better.
Do you remember? Goes around, comes around.
Manipal Academy of Higher Education.
Technology, it's transforming lives, every day and in every way. But learning technology through hands-on experiences is what enables you to create different things, build different structures, and move things in different ways. And one institute which has been striving to make technology education experiential for more than 60 years now is Manipal Institute of Technology.
It is way back in the year 1957 that our founder, Dr. TMFI, founded this great institute, Manipal Institute of Technology. Today, we have undergraduate programs being offered here and post-graduation offered in almost all spheres of engineering disciplines. The syllabi of any engineering discipline is changed as per the requirement of the industry, and the students here undergo what is called as experiential learning.
What creates the necessary academic foundations for experiential learning is an outcome-based approach and flexibility for students to choose what they want to learn.
Manipal Institute of Technology shifted from textbook-based learning to outcome-based learning. Each course outcome is specifically designed to help us when we go out to study or to work in the industry.
Along with the predefined course which we have, we also get to choose open electives and program electives. We can explore many other domains like humanities and other disciplines.
With such a multidisciplinary approach, students here are encouraged to solve real-world problems with various student-driven clubs.
Manipal Institute of Technology is not only the academic learning what is taught by our teachers, but instead believes in what the student wants to learn on them. A major aspect of this is the student clubs.
We tend to learn a lot of things from this project. First of all, we learn hands-on experience if we are working practically on a project and not generally studying a subject. And secondly, what is required work at
Online learning platform have been around everywhere. Our students have taken online courses like Coursera is one very important platform which our students have been very drawn to.
The opportunity to pursue research plays a critical role in developing students' capabilities. Dedicated infrastructure, experienced faculty, and financial assistance from the university goes a long way in this pursuit.
In MIT, there are various research programs which are funded by industries and government funding agencies. Students who are working in these funded projects can also apply for PhD programs. To fulfill the dreams of future researchers, MAHE provides scholarships to a number of students every year. In addition to this, the students are given various opportunities to present their papers in conferences, and the university provides financial support.
Sports and cultural activities are vital for holistic development of a student. And we have created an ecosystem for students to excel in their passions.
Our college offers a lot of activities and platforms for us. We have Marina near our campus, which is the sports complex where we can go and practice a lot of sports. We also have different cultural clubs. These clubs not only participate within the college, but also go and participate in different national cultural fests.
The exceptional placement record is a reflection in itself of the industry's trust in Manipal's quality of students.
MIT offers place-around placement opportunities. We are coming up with a centralized online placement portal where our students will be trained and it will provide an environment as conducive as how a company conducts its online tests here. We have further plans to introduce more group discussions as well as mock interviews, which will help our students to be prepared for their actual interview rounds. In context of entrepreneurship, MIT goes with this look with our
Ladies and gentlemen, welcome back to the next session of our year 2024. If you have any friends who are waiting outside, please request them to join us for the next sessions. We'll start in the next 1 or 2 minutes. Please request your friends to join us back during the session.
बंद
Alright then, ladies and gentlemen, you have all received one book outside called The Planner, isn't it? So this is a time management using Harmony Pages planner, and we have with us the person who has designed this special planner. This is advocate engineer Mr. Pranav Bhatt. He's here with us. A round of applause for him, please. Well, an unusual combination, isn't it? An advocate and an engineer. He is a BTech in Electronics and Communication Engineering. He has a degree in law, LLB in IPR, and he's pursuing his doctorate in geophysical indications. And then he's a consultant to multinational companies, including Manipal Academy of Higher Education. He is a winner of Elevate and Nidhi Prayas grants. With this brief introduction, ladies and gentlemen, please welcome Advocate Engineer Pranav Bhatt.
Good morning to everyone. So I believe everyone have a copy of this book, is it? Yeah. So the inspiration to do this book came when I was discussing with my sir, and sir used to say that million things run in your head and you're so much chaotic, you don't know what to do, you only say you have lots of work and you exactly don't know how much work you have. So first thing that I got to know was I'll have to write down what I have to do, and when I write down, everything looks important, isn't it? So first thing that realized is this is not only the problem for me, it's a problem for everybody who are around us and trying to do a lot of things in a limited amount of time. So in order to solve this problem, we wanted to share a solution with the entire world. Again, this book is a compilation of solutions, and that found or that could be a best fit for academic researchers like us. Okay, so please open the book. If you see page number 2, the second page itself. Okay, you have a sample about how do we fill this. So firstly, we have a session called brain dump. So you can put all the things that you have to do in a day, and I suggest you to do it as build and non-build. So non-build are those favors that you do, which has probably low ROI, and to do are the things that you're supposed to do, right? And second thing is, when you have the tasks that you're supposed to list it, you need to prioritize which task to do, which task to eliminate, right? For this, there is something called Eisenhower matrix. I did not come up with it, Eisenhower did, but we could fit Eisenhower's principles in this book. So when you list out tasks, you figure out which task is important and urgent. That you only get it done. If a task is important but not urgent, you can schedule it. And the tasks that are urgent but not important, you can delegate it. If something is not important and not urgent, then don't do it. Okay? So this Eisenhower matrix will solve a lot of confusion. And once you're scheduling it, there is something called time boxing. This is a principle that we have learned from Elon Musk. So he basically runs three biggest companies in the world, and he still has time to respond to some random guy's tweet in Twitter, right? So how he does, because he has scheduled 30 minutes in a day to tweet, right? So how he did it, he time boxes everything. So you can see a time boxing here, correct? So let's assume your schedule starts at 5 a.m. and ends at 11 p.m. This is not for someone like me. My schedule starts at 7 and ends at 10. So this is probably an efficient way to look at things for those who are super productive. Okay, and you can see in the next page how you can fill it as well. Okay, so to do, we have some build projects, some non-build projects. Then how do we say we are going to plan our day? Then how do we use that Eisenhower matrix efficiently? So in the to-do, we have client meeting. Okay, client meeting is something important I'll have to attend. So I'm putting it in the time boxing. That is, I'm allocating it 9 a.m. Then accordingly, I'm planning my whole day. So point number 1 is brain dump. Just put whatever you have to do. Point number 2 is put it in the Eisenhower matrix and take the decision. Once decision is taken, plan your day using the time boxing. So usually I'm doing this for quite some time. This is probably I'm at least able to achieve 80% of the things that I've planned. And most importantly, I do not have the conception that I have a lot of work to do. I exactly know I have 4 hours of work to do. Because whenever I have work, I allocate. This work means 4 hours. I exactly know how much work is done. So this gives me some help when I'm planning for a long vacation or something. Okay, I'll have to do about 40 hours of work and get done. So basically, even though we want to work 8 hours a day, our effective productive time is about 5-6 hours. But if you time box, how much your work you commit, you will be able to do it, because whenever you allocate a work, you put a buffer and say, isn't it? So okay, this is 30 minutes work. Let me put 45 minutes to it. Now you are going to put that 45 minutes in the time boxing. Now that is eventually going to happen. So this has probably helped. And along with that, some of the other important and interesting features are, you can plan your week, also your month. You can, if you go to the next page. Firstly, you select which month it is. Then if you have some important meetings in that month, or any plan or any holiday you're planning, you can put it here. And we have also given you one option. If you want to binge watch any series, you can list it. And this is also eventually going to be there in your time boxing, isn't it? And what you want to shop, everything can come here. And once you have clarity over the month, then you can plan your next week, right? And same thing. So once this is done, you can go to the end of the month. So basically, I'll just show it to you. In the end of the month, you can review. Okay, so basically, there are four set of this given for every month that constitutes to a month. And another important thing, you don't have to categorize this as Sunday, Monday or something. This is day 1, day 2. You can start, your day 1 can be Sunday also, your day 1 can be Monday also. It doesn't matter.
right? So if you're, let's assume that we heartily and genuinely want to do this, but eventually we will miss it. Then about this much page is lost, isn't it? You don't have to do it. Whichever day you start, it is your day one. And day one can start and reset at any point. So that is the flexibility this planner is giving. This is a unique kind of a planner. So to do this planner, we have gone through about 5-6 most expensive and probably highly recommended planners, and we figured out that this can give the flexibility and the opportunity for anyone to start planning and making from the day one. Whichever day they start is the day one. Okay. And in the end of the month, you can summarize. You can give you a score how much productive that month was, and you can say what professional objectives and personal objectives you have achieved, and some of the memories that you have built. And also, if you want, you can run on a habit tracker. They say if you do something for 21 days, that becomes your habit. So you can do a habit track, habit builder marathon as well. Okay. So yeah, pretty much about it. And if you have any queries in making the best use of the book, you can raise it. We'll be able to help you. Yeah, I've been using it for quite some time. This is my second book. So
I suggest give you a suggestion. We also did this for our company.
Okay.
What we did is, instead of you using these pages, we got it laminated so that you can use ink pen and reuse it again and again.
Right.
Instead of changing. One more suggestion is use the whiskey by hotel to analysis. Where, why, what, when. If you list down where, why, what, when, at least you know which is urgent and important.
Right.
Sometimes you will not be able to decide which one is urgent and important.
Good.
So when you write down where, why, what, when analysis, then you can bring that to this is really urgent and important, and everything is important.
Okay, nice one. We'll consider it. Yeah. So as far my knowledge goes, about 2,000 people are using this. So it's kind of it's working out, especially for people who are in academics and people of my age who are basically students who wants to do everything, even though the proverb says you can't have the cake and eat it at the same time. This helps you to do that. Okay.
There is one suggestion.
Yes, sir. Yes.
There are some activities that is not important, but we are bound to do first.
Right.
Not important, but we are bound to do first. So make the category.
So basically, sir, if you see this when you're planning your week, there is something called top objective shopping binge. Binge is something what I watch on Netflix. So basically, we can time box it. So this is going to help, even though it is not that important. So how I actually use it is I have 2 hours in a day. It is not planned to do things. Those are kind of what you say not built or related to professional work. So that is how basically time boxing. It's about up to us how do we plan our time boxing. Right.
Not important, urgent mein jayega. Not important, urgent mein jayega.
So I have 1 hour in a day just to do that. Yes. So how Elon Musk plans his Twitter reply. Yes. Thank you. Thanks for the time. Yes.
I have a suggestion. Why don't you launch an app?
Right. So that is too much of digitization. You know, why people are going back to pen and paper. So that's because too much of digital toxication that is happening. And what I observed is even the people who are very much struck to Notion, such things, they are also coming back to pen and paper method. So this is what I have observed. So I think if we are riding that wave early, I think in another 2 to 3 years, again, a moment is going to start that work only 3 days work only 4 days a week, take a digital break. I think it is going to come. So considering that in mind, I think pen and paper ultimately. Yes. Thank you so much. That's a suggestion that is valid, but people have their preferences. So I go with pen and paper. Thank you. Yeah.
Thank you, Mr. Pranav, and thank you everybody for keeping it interactive. So ladies and gentlemen, now we move on to the keynote speakers of the day. We know that it is very customary and it is imperative to have keynotes when we say it as an international conference. We have our first speaker for the day, Dr. Mayuk Das. Before I welcome him on stage. Let me introduce him to the gathering. He's an eminent researcher in the field of AI. He's a senior research scientist in the M365 research group at Microsoft India. His research is broadly in the area of AI ops, specifically sequential decision making in complex, uncertain environments, primarily targeted towards solving efficiency optimization, reliability, and safety challenges in enterprise clouds. Prior to Microsoft, he was with Samsung Research Bangalore, working on optimization and design of AI/ML models for resource-constrained devices such as smartphones or cutting-edge devices. He has many patents as well as multiple research publications in flagship conferences and journals such as CIKM, NSDI, KBS, SDM, Frontiers in AI, and so on. He also serves in the program committee of several conferences, including ICLR and AAAI, EMNLB, etc., and as a reviewer in several journals, including MLJ, JAIR, Frontiers, etc. He was also the demo track chair for COTS Command 2024, and he is the topic editor in Frontiers in AI Journal. With this brief introduction, I request him to please take the dais. Dr. Mayur Das on stage.
Thank you everyone for inviting me today to this great conference, and thank you for this nice introduction. So I'm from Microsoft. We are a group called M365 Research Group. M365, you know, is like the suite of tools that Microsoft offers that includes your Word, PowerPoint, Edge, your Excel, and so on. And there is like a suite of like 20, 30 different tools that come together as like an ecosystem. And it's offered as installables on your own laptop. It's also offered as like a cloud provided entire suite of tools that you can directly use from the cloud. Right? So we are a research group embedded inside that ecosystem. Our research yeah. Can you hear me? Yeah, that's too loud. Am I audible? Oh. Yeah, so we are from that research group, and our research delves into the space of both AI and systems research. As in, our research is related to making AI work for making all of these cloud systems work better, or rather applying AI or adapting AI such that we can make these cloud systems work better. So yeah, on that corner is my motto that I personally follow, and many of my peers do as well. We call it science over spectacle, as in we encourage everyone to understand the science behind the hype that is going on in the world before believing in that hype. So yeah, so the talk today is about augmented reinforcement learning, where I talk about how reinforcement learning plays a role in many of the problems that we solve, and I talk about how like taking simple reinforcement learning ideas from a book doesn't solve all the problems that we need to solve, doesn't solve all the nuances that we face every day, to make like a robust cloud system that we want. And how we augment it with different kinds of solutions and different mathematical formulations and so on. This talk essentially has 3 sections so that like you don't fall asleep. I'll try to go through it fast. And first section is like a slight primer on what I'm talking about, sequential decision making, which is like a umbrella term people use for reinforcement learning, planning, decision making, and so on. And then I'll talk about the challenges of decision making in the wild. In the wild means when you are actually trying to apply decision making frameworks on real problems. That's when we call it wild. And that includes the problems that we solve, that includes things that we are super excited about from Tesla, which is trying to build like automated cars and so on. So that is also decision making in the wild. But I'll focus my talk on the problems that we solve. And then finally I'll go through the nuances that I talk about here through some of the scenarios that we solve, right? So that it's clear to you. So what is sequential decision making? We know that like normal traditional predictive modeling, even the deep models, essentially means that you have a target variable, you have a bunch of like feature variables, and then there is a cost function which is getting a cost between your predicted value and your actual target value that you get in the data, right? Now this is like a one-step prediction model that you can build, but in decision-making problems that you cannot be happy with that. In decision-making models, it's a dynamic environment. Whatever predictions you make is going to affect how the environment looks like in the next instance, right? So that's why we call it sequential decision-making, and it's essentially understood mathematically as a state model, as a state transition model, right? A state machine, so to say. And here, the difference between traditional predictive modeling and sequential decision making is essentially how the cost function looks like. Now the cost function is not just this one-step difference between what your predictions are and what the true values are. It's a expected cumulative sum over the costs until the horizon, where each cost that you measure is added to the cost at the next instance, because the next instance your predictions are with respect to changed feature values because of the predictions that you have made now. So your cost computation also changes in the next instance, and it goes on till you actually stop on a certain goal, or you stop forcefully. So that's why sequential decision making is like a cumulative sum of costs. And we know that, we know that sequential decision making has like a bunch of paradigms. Some of you are familiar with them, some of you may not be. So the paradigms are these kind of paradigms. One is automated planning, which people used to do like 1,000 years ago, and there is a community that still does it, but somehow people are more excited about other things. But it's equally important. Planning is essentially where you have a world model, you don't have any feedback from the world, you don't compute any feedback from the world, and then you do a logical inference and you find out the steps that you have to take to achieve a certain goal, right? That is planning. Then you have multi-arm bandits, which is essentially saying that you have a feedback from the environment, but you have no notion of what the environment looks like. So in that case, all you're measuring is like a probability distribution of which arm you should pull such that you get the most money, or rather which action should you take such that your total collected reward is the highest, or like it has the higher probability, right? And then we come into the space of actual RL, or reinforcement learning, which is called learning by trial, which means that it's the full RL loop. You make a prediction, you have visibility of what the environment looks like, which is called the state. You have visibility of feedback from the environment, which is called a reward. And then you do a bunch of computations and you end up learning a policy, which is a probability distribution over the actions or the decisions that you need to make given the observations of what the environment looks like at a current state, right? So this is a whole distribution function that you learn. And then another form of RL is called learning from demonstrations, where we say that you don't have the privilege to let your agent loose into the environment. You don't have the privilege to let the agent make mistakes, get feedback, make less mistakes, get more feedback. So you don't have that privilege. What you do is that you have a teacher, or rather you have books, as you call it. So what that means is that you have past trajectories of decisions being made and feedbacks being collected and observations being made. So they're called trajectories or transitions. You have that data and you somehow fit a probability distribution, a new probability distribution from the underlying probability distribution in the data. So that is called learning from demonstrations, and all of that imitation learning, offline reinforcement learning, everything falls into that bucket. So this is a primer. Now why are we interested in this? Because our team research agenda, one of the highest priorities we have is something called AI Ops, which means adapting AI techniques, methods, and science to solve problems in cloud business, which means in achieving operational efficiency, operational reliability, and operational sustainability in our cloud business. So that is the space of AI Ops, and that includes a bunch of areas. I've listed 5, but essentially there are more. And if you look at all of them, you'll realize that we need adaptive solutions for everything. We can't just predict once and be happy that, yeah, we made a right prediction, and then we can go home and sleep. That doesn't happen. So we need to build solutions that adapt to the changing workload, changing patterns of usage, changing requirements by the clients, and so on. So we call it beyond prediction. Essentially, we need to make temporal decisions, we need continuous control, we need sequential decision making. And I think this is the burning question in everyone's head, like, why is this guy talking about all of this when we have generative AI? So yes, I'll talk about generative AI, and we'll see that this generative AI also plays a key role in many of the things that we do here, but I'll show it from an angle of sequential decision making. Right, so what are the challenges of decision making in the wild? Firstly, I call it systematic noise. Many people call it that actually. And that gives us safety challenges. Why? Because we have observational noise. Sometimes you can't see the condition of the environment in the right fashion. Some variables are unobservable. In some cases, exploration is tricky. Like, you can't explore and see what the next thing could be, right? Feedback noise, which is like the feedback that you're getting from the environment for taking an action, may be ill-defined. Like, you did not define the function correctly, such that whatever you observe as a feedback can be translated into a number that can be used by your algorithm, right? So that's not correct. Then there is noisy reward, like whatever you are seeing as a feedback is probably not what was generated. And then delayed feedback, like you get the feedback late. You already would have taken more steps before that. And then there is a credit assignment problem, which means that not all states, not all observations will have a feedback attached to it. Maybe you take like 1,000 actions, then you at the end, at the goal, you see some feedback, right? So, and then there is distributional noise, which we call as domain shift or non-stationary environments, as in your assumed distribution of what the observation should be, what the action should be, and how the state changes from one state to another, that shifts or changes at runtime. And even in offline setting, where we are learning from data and not letting the agent learn on actual environments, there are even more nuances, as in like sometimes the ground truth is not actually ground truth, it's some observation. Sometimes we don't know the granularity at which we can learn the decision space. And then there is domain shift as well, like because what you learn from the data may not be reflective of the actual distribution at runtime, at real time. And I'll not go through this slide, but all of the problems I mentioned in the last slide essentially end up in two main things. One is you end up learning policies that are unsafe. Unsafe means that takes or predicts actions or decisions that will lead you to an uncertain or an adversarial state, like where you are like there are damaging consequences, or your exploration is unsafe, as in like you can't explore safely and see what the condition would be if you take an action, because you don't know if for example, can you explore whether falling off a cliff with your car is going to damage your car or damage your life. Like you can't explore that. We already know that because we have been ingrained with that fear, but an AI agent doesn't know that, and maybe we have to ingrain the AI agent with that fear, right? So all of that boils down to these two main issues. And again, why are we worried about this? Because that unsafeness or like that lack of safety is a no-go for our research in Microsoft, especially in AI ops, because applications are safety critical. Telemetry that we record, that we are so proud of, that we have so much data that we can look off of. That most cases they are noisy and partially observable, and even if we build RL agents on simulators with a lot of engineers who can help and they can give their opinions and expertise, simulators in most cases do not reflect what happens in real scenarios. Anyway, and one more important thing is this unknown exogenous disturbances, which is domain shift, as in at runtime, after deployment of a certain policy, there would be situations where which is due to some exogenous process that has changed your environment dynamics, and in those cases the RL agent wouldn't know if its action is correct or not. So yeah, so these are the general ways in which people solve these challenges, particularly in sequential decision making. One is noise reduction, like you generate more samples, more correct samples for noisy areas. I wouldn't be talking about that space. I will focus on these two. These two main important areas is, one is constraints. You design constraints in such a way that you can manage that safety risk. And other thing is called knowledge augmentation, infusion, or guidance. You somehow add or infuse or guide your RL agent or sequential decision making agent in such a way that it is able to manage that safety risk. Again, that burning question is like, why is this guy talking about all this? Cannot Gen AI save us? Maybe, but as I said, science over spectacle. Let's see. So I'll go through some of the scenarios. I'll try to do it fast because we are almost out of time. So the scenario one we call knowledge and constraints in imitation learning. Here the actual industry problem is called oversubscription. It is similar to flight overbooking, as in like airlines overbook your flights. That means they sell more tickets than the actual number of seats on the plane, right? Why do they do that? Because like many people would be no-shows and they will lose money if they would have booked same to same as the number of seats. So they overbook, and if some people don't turn up, they don't actually lose money on the empty seats, right? Same thing happens in cloud as well. They offer resources to more entities or more users than their actual physical capacity. Assuming that not all of them would have peak workload at the same time. So if somebody has peak workload, they can assign more resources at runtime, and because others are not using extra resources, right? But there is something called oversubscription margin or oversubscription ratio, which means that how much extra resource would you allow somebody to use if they're at peak workload, even though you have packed more people into a physical server. And that margin, that decision of that margin is extremely important, because if you are aggressive, if you are packing more people, it would lead to contention, resource contention or jitter. So this is a resource management problem, as you can think from here. And if you have a conservative policy, which means that you give more resources to every user and you don't pack more, then essentially you run into the problem of like inefficient usage, like you incur more costs, like in a plane, right? And the other challenges are like demand patterns are varying. You don't know the granularity. Should you decide this margin at every VM level? Should you decide at every client level, or groups of clients, or industry level, right? And then the safety challenge. Does online RL work here? We have tried. We have actually tried to train online agents on prod or pre-prod environments directly. But then, can we really train online? We have seen that it's not safe. We cannot give safety guarantees. Two is like we don't know how to design a good reward, because it's a multi-objective problem with competing objectives. You have to optimize the cost you are trying to save, and you have to optimize the safety risk or minimize the safety risk that you incur, right? So on this note, what we did was, because Microsoft has a lot of telemetry, as I told earlier, that what has happened before, like last 3 years, how has been the usage, right? So we take that, we use imitation learning to learn a policy, but the traditional or the standard imitation learning did not work well, because one is like the generalization across different granularities, and the second problem is like we have to manage the safety as well, because like the data is noisy, right? So we propose two methods here, both of which like are like one is patented, another one is published. One basically what it does is it learns symmetries of patterns or equivalence groups called prototypes, and then from the prototypes it actually learns a policy. And the interesting thing here about handling safety is this part, where the model knows what it doesn't know, as in where it's not confident about its own decisions. In that case, it can query and it can get more knowledge. And where does that and more knowledge about whether these groups are correct or your decisions are correct or safe rather. And then where does this knowledge come from? This knowledge comes from either a human expert or a cloud expert, or this knowledge can come from an LLM, GenAI. Yeah. So this is where GenAI starts. So we do this. And then there's another method where it's the same problem, but where we show that there is uncertainty in the telemetry itself, as in each record in the data set is not actually a point estimate. It's a Gaussian distribution over multiple estimates. So it creates an aleatory uncertainty, as we call it. And here we solve this by adding some stochastic constraints or chance constraint, as we call it, and basically that hedges the uncertainty risk. I'm not going into too much detail here. So we see that so this is the safety risk, this is the benefit, and we see that the safety risks are almost close to zero for our methods, and the benefit is much higher than the best baselines. This is scenario 2, which is like you will all like to use Teams and Slack and whatever to do your video calls and so on. So all of it is called RTC, real-time communication. And congestion control is an important part of that. Like, how do you control the congestions that happen due to the network unreliability? And bandwidth estimation is a key part there. Bandwidth estimation means like all of these models that are running on your teams, for example, resolution control or noise suppression or something, all of them need a bit rate as an input. And to decide the bit rate, you have to predict what is the bandwidth in the next few minutes on the client side. If that is the case, then this is an important problem. So what is the actual issue here? Firstly, we cannot train online, as we have established. Two is like at runtime, after you deploy your policy, there is exogenous disturbances or exogenous processes that affect the network like you have never predicted before. It's unseen. You don't even know how it will affect and how the network is going to be, right? So whatever policy, whatever best policy you can learn actually fail at some points in time. So what do? We propose this method where we don't just learn a policy, we learn a detector which detects intermittent disturbances in your environment. And it's applicable not just for RTC, this problem. It can be applicable for any problem where you deploy a policy and where your environment can change arbitrarily at runtime, right? So we learn the detector, and the detector along with the policy, we actually at test time, we don't change the policy. Instead, the predictions that the policy makes, we can slightly alter that towards better predictions, right? So using this detector. And we see that it's called streetwise, which means street smart. And we already see that our MOS scores are actually the actual user metric. That's much higher than all of the baselines. And okay, so now we are in Gen AI. The last two scenarios are Gen AI, and I hope people will be happier. So this is called the suitable reward learning problem, where I have talked before, we don't know how to design a reward. In most cases, manually, if we sit down and come up with a reward function, it is highly likely that we haven't taken into account all the metrics that needs to be compiled into it, or how to even compile or like compose all of those component target metrics that you are trying to collect into a function that gives you a reward value, right? So, but what is easy for these cloud operators or engineers or scientists to do is give us specifications. They can tell us what needs to be optimized. They can tell us any special considerations we should make. They can tell us what needs to be maximized, minimized. They can tell us in the nature of the quantities that we are tracking. And we take all of that as text. We take the entire cloud stack, or even for other problems, we take the environment code. We run an LLM. We were actually able to like recommend very optimal reward functions which could then actually help us learn the best possible policy. And we have shown in a workshop paper that it works pretty good, right? So this is called a reward co-pilot. LLM Gen AI is helping you design your RL problem itself, so that we don't have to sit down and write down the problem, encode the problem. So it's like a GitHub Copilot where it helps you write code. Here it helps you write the problem. So it's like a problem copilot in some sense. Gen AI, yeah. And then finally, this is not my work. I wanted to highlight this. This is one of my colleagues, like for a few of my colleagues. So this is a big thing in Microsoft, where not just Microsoft, like any industry which are cloud operators, they get like thousands or tens of thousands of incidents reported to them every day. And if all of these ASG groups sit down and solve each of them manually, nothing would get solved. So what we are trying to do is like entirely create an intelligent pipeline to solve them. RCA means root cause analysis and then mitigation. So LLMs help you understand the root cause from the incidents and the metadata and the historical troubleshooting guides and so on. It takes all of that, does fine-tuning, does RAG and so on, and finally gives you RCS, root causes, and then mitigation plans. Mitigation plans are the part where sequential decision making comes in, right? So it gives you mitigation plans with some confidence estimations as well. So this is a big thing that is going on in Microsoft as well, and I think like many other industries are also interested in this. So that kind of concludes all of the scenarios where I have tried to highlight that, hold on, where I've tried to highlight that decision making in the wild is this huge wild space where you have cloudy skies, dark, and then you have decision space which is like changing at all time. You have safety and systematic noise concerns and so on. And we want to be a beacon like this lighthouse, right? And what does this beacon lead to? Like there are a bunch of landscape of methods and paradigms, and we would like to consider that we are here. So all researchers would like to consider that their methods are at that corner. So that's a privilege I'm going to take. So thank you. And this is a slide with all the links. This is our research group. If you want to visit, you can. If some of you are interested in like applying for internships or research fellow programs, or your students are interested in applying for research fellow programs, please do. There's a QR code as well, which will help you get to the website. Thank you.
Thank you, sir. So always a tricky question, decision making.
Yeah.
So a nice topic to touch upon. Thank you very much for joining us here. I request our convener, Mr. Nitesh Naik, to kindly present a memento. And applaud louder. Thank you. Ladies and gentlemen, the next keynote speaker for the day is Dr. Richa Sharma. Dr. Richa Sharma is an associate professor of mathematics at J.K. Lakshmipath University, Jaipur. Her research areas include quenching theory, probability theory, reliability theory, stochastic modeling, and optimization. Dr. Sharma has published 57 research papers in revered international and national journals and holds 4 patents granted by the Government of India. She has presented her research at various international conferences across the globe. She is the recipient of the Best Researcher Award and from the Institute of Technical and Scientific Research and Institute of Engineers, Rajasthan State Center, Bharat Excellence Award and Leading Educationalist Award, to name a few. With this brief introduction, let us please welcome Dr. Richa Sharma on stage.
Good afternoon, all of you. And I want to share that I will take only your 10 to 15 minutes, and those 10 to 15 minutes will be, I try to fruitful from your side, and you will be gain something from this lecture. So I'm not going to go to in detail, but try to cover those points. Dr. Das already covered lots of points of mine, which I am going to, discuss here. So I'm not going bothered on those topics. As Dr. Das conclude with the, blocking of the data set, he has started with the state transition diagram. He has also mentioned about how to develop the constraints for optimization. So I start from next. He has set this bar, I will start from this bar, okay? And thank you, Dr. Das, to cover most of the point which I will cover, so you already save my time. Let me first congratulate all the conveners to inviting me. Thank you so much. So today I will talk on signal analysis in communication system, a queuing based approach to the buffer handover scheme. Yes. So here you can I have a pointer please?
It's not work, ma'am.
It's not working. Okay, it's okay. It's okay. So the buffer handover scheme. So why the buffer handover schemes are very important, as Dr. Das already mentioned, lots of data are bothering every side. So it is the requirement to control that data set. So to control that data set, the buffer handover schemes are utilized for the mathematical modeling. So with the help of the buffer handover scheme, we can control that data set. So lots of buffer handover schemes are there, buffer management is there. So what we are doing in the buffer management, we put some data set into the queuing theory in the form of the queue, then we can control, we can assign these calls are, these data are very important, which to be further investigate for the further analysis purpose. We can assign some blocking also. So lots of buffer handover schemes are available. I will cover one of them. So today I will be cover the buffer handover scheme. Then come to the signal analysis communication system. Then the queuing theory. Yes, queuing theory is my research area which I will apply in the signals communication system, and the queuing theory can be also applied into the telecommunication system. Network system, where we have to transfer the data from the one node to another node with the help of the various buffer handover scheme. I will also show you how to apply this queuing theory in the signal analysis. So yes, here you can observe in the middle, so this is the queue, queue. When the data arrives to somewhere else, means we are making a call to someone, and at that same time many other person are calling to the same person, so the lots of calls are there. So we can put all the calls into the one queue, and which is very important. Suppose something urgent is there, so we can prioritize those calls to first transmit it first. So in this way data packets arrive, make the queuing system and make the buffer, and in those buffer we will prioritize, we can control, lots of queuing theory tools are available, and after that we can transfer those calls to the another destination. So this is the all about the queuing theory, which we can apply either in telecommunication system, network system, and wireless communication system also. So here you can, this is the very basic figure, user, we all are user. There is some network is there, and what we want to transmit it, our data set to the another person is treated as a server. So queuing theory play a role between, it is the bridge between the user and the server for providing the better service. So here you can observe the buffer handover scheme using the queuing approach is a method used in computer networking, telecommunication, to manage what? To manage the data packets between the nodes. In this approach, which is queue, which is the data structure, store and manage the packets in the first in, first out. Obviously, we being a human nature, we all want, if we arrive early, we get served early. So the same manner, this is the particular phenomena in the queuing theory people applied who are working on the queuing theory. Those packets, those data set, those calls, the data are in the very first queue, will be served very first time. It is the first in, first out manner. And then this we will apply in the handover process that ensure, this is very important, because dropping of the message, we are, as Dr. Das told, develop the function by considering all the constraint. So when we develop the model, so we have to focus that dropping of the messages is not allowed. Dropping of the packet is not allowed. So we have to develop the model in such a way that we can provide the quality service to the user. So this is our priority. When we define the model, so we have to keep in mind that quality service is very important for being the end user. So you have to develop the system like this. Yes, as I told you, buffer management, once you assign the buffer handover scheme. So in buffer handover, there is an umbrella buffer handover scheme, and there is a one term is buffer management. So what is buffer management? Techniques employed to prevent the congestion and optimization. So Dr. Das told that lots of, blocking are there. How to control that? So there we can apply the buffer management. Threshold, how we do the buffer management, we can give the threshold, means this type of the data serve first, then we allow the other person to accumulate that particular queue. So this helps in analyzing the network traffic patterns by modeling the arrival of the data packets and then processing to the network administrator, which can predict the congestion and optimize the network capability to handle the varying level of the traffic efficiently. Queuing theory is the fundamental to understand how the packet switching methods operate in network, especially in the telecommunication, where we have to take consideration of the quality of the service. Prioritize means you want this packet, this data is very important, you try to transform this first. This is known as the packet prioritization. As in the doctor clinic, if some emergency comes, so if I am the patient and I am getting the service, so doctor immediately interrupt my service and immediately go to the ICU because this is the priority. So in the same way, the same model we can also apply here in the data handling purpose. Optimization, handover triggers, dynamic bandwidth allocation. I'm not gonna read all these documents. These are the basic terminology in the buffer management umbrella. Yes. Now here comes the basic queuing structure. As you can see here, the arrival of the customer. So customer can be anything. It can be your calls, it can be your data set, it can be anything. So here a customer arrivals, which forms a queue. Then the server decide by assigning some rules. It could be first come first serve, it could be last come first serve, but generally we prefer first come first serve. So rules are assigned by the server, how he has to treat that data set. So now coming to the signal analysis. As I have started that, I will tell you how the buffer handover scheme with the amalgamation of the queuing theory we can apply into the signal analysis. So originating signals. Originating signals means we are the person. If I am making a call, so I am making the signals. So these are known as the originating signals. Then it comes to the queuing system. Then we decide the priority signals. And then after we hand off. Hand off means to transfer the data set to the final destination. Buffer. It is the optimization control. We can control the buffer size because lots of data are bothering everywhere. So how to control this data set? We required buffer. Then final, after applying these all queuing theory methodology, we can transfer the further communication to the destination. So here you can see ongoing signals are arrived. Then we decided which are the priority signal. Then multiplexer is the technique which among the many, you can see A, B, C, Z, lots of data calls are there. He decides which one is the best and convert to the final destination service signals. And demultiplexer is the reverse operator of the multiplexer, does the reverse operation. So for developing something, suppose now the question comes, this is all are the things, how to develop the model? This is the question comes to everyone's mind. Yes, we know this buffer blocking, we know priority, but how to develop the system? So here is the slide. So the queuing of the handoff and originating signal, I just consider the two type of the signal for this particular study. You can consider many. So these two type of the signal I have considered under the buffer size. Why are the buffer size? Because I give, suppose I'm just taking the small number, suppose 10 data sets are there, then I will be transmitted those data sets. You can choose any of the number. I'm just citing an example. Again, by first come first serve and with the help of the priority signals. So for this, I have developed the mathematical model. These are the some assumptions which I have considered to develop the model. I'm not going to read these. These are the one or two I can read. System is having the fixed number of S databases, means S is allowed. So this means I have given some control. I am not going to serve. As this auditorium having some fixing capacity, if some person more than comes, so they have to either stand behind the amphitheater. So this is the controlling of the queue we can control. And one or more databases are available. So how we have convert this? These are some mathematical notation as I have given as to the fixed number of the databases. These are the probability, as Dr. Das told about the probability distribution. Yes, distribution plays a very important role in developing, in modeling any of the real life scenario. So arrival rate of the handoff scheme, because I have considered the two type of the signal, handoff signal and originating signal. So arrival rate of the originating signal, then service rate of the handoff signal. These are the notation mathematical I am just assigning. And then by considering this, here I have provided the state transition diagram. Sir has shown a particular one state. This is the complete scenario, because I am just generalize the complete picture. So you can, S buses are there. You can pass on any value to this S. This is just particular, I am just go to the just look at the very first state, S plus E and E. These are the arrival rate, means what the rate the data signals are arrived to the system. So this is the state transition diagram you can develop to your model, and then we can formulate the governing equation for this state transition diagram. These are here. These equations develop using the inflow rate and outflow rate. When you pick up one node, what the outflow is there and inflow is there, by balancing rule you can develop the, don't bother by seeing this complicated equation, because I have developed the complicated system, so that's why this is the complicated equation. You can start with the very smaller one. So once you have developed the governing equation of your developed system, then you can find out, yes, performance indices. Your system designer is only interested in this performance indices. They are not interested in what the mathematical calculation you people have do. So the system designer want to know the blocking probability of, I have considered the two type of the signals, so blocking probability of the two type of the signals. If you have considered more than signal, we can find out the more than blocking probability. So we once we have developed those state transition diagram, we pick up where the blocking of the probabilities is there, then we sum up to develop this formula. Blocking probability, then traffic in the system. Traffic in the system, these are the formulas which we have developed. So these are the sum of the result, numerical result. As the time increases, you can observe as the time increases, quality of the services also increases for particular this study. For the calculation purpose, we have used the MATLAB software. Yes. So I would like to conclude. Yes, for queuing theory, we can apply any area by using the buffer management system and optimize the resource utilization. Whatever the resources are available to use, you have to utilize in the fruitful way by providing the quality service to the end user. Yes, reliability also. What the system you have developed, reliability also plays a very important role. You have to work on the reliability. Improve the user experience, support for emerging technologies, network capabilities. Yes, so I am just extended this research with the help of my one fellow colleague, Dr. Girish Kaushik. I am just taking the help of him in applying the automation into this study. So we are just taking the data set, then with the help of the automation, we provide the better signals. So these are the future work which we are right now in the pipeline and we are working. So this is all over from my side, and these are the references. These are the some of the published paper, credit to me. And I am again happy to work. If any one of is interested in this particular area, you can contact me. Happy to work with anyone. Session is open to question and answer.
Any questions, anybody?
We can have a question over the lunch because everyone having butterfly in their stomach. I can see the faces.
Thank you, madam. Thank you for the energetic presentation. Thank you very much. And may I now request the convener of the conference, Dr. Princey, to hand over a moment to madam. Thank you, Varun. Now, ladies and gentlemen, we shall move on to the another activity or an important activity of this particular session, the panel discussion on the theme of AI in action, transforming daily life and driving industrial innovation. We have various experts participating in the session, and the discussion will be moderated by Dr. Dashrath Raj Shetty, Associate Professor in the Department of Data Science and Computer Applications, MIT Manipal. Before I request him to take over, it is my duty to introduce him to the gathering. Dr. Shetty, as I mentioned before, is a member of the faculty fraternity of MIT. He is a computer engineer who holds a doctorate in computer vision, an MBA in finance, and an MPhil in management. He has more than 100 publications in Scopus and Web of Science indexed journals. He has 16 design patents and 4 utility patents. And he is a co-founder of Ganglia Technologies Private Limited, Manipal, and a faculty member, as I mentioned before, in the Department of Data Science and Computer Applications. He also serves as the Vice President of Micro Sauharda Cooperative Limited, demonstrating his dedication to fostering financial inclusion and cooperative development. Dr. Shetty is also a certified management trainer accredited by the All India Management Association. His excellence in management has been recognized with various prestigious certifications of excellence from Ramakrishna Bajaj National Quality Awards. Most recently, India Today magazine honored Dr. Shetty as one of the top 10 leaders instrumental in maintaining India's position as a global bright spot in 2023. With this brief introduction, I request Dr. Dashrath Raj Shetty to take over. Over to you, sir.
In the meanwhile, in the time they arrange the chairs and the podium, yesterday I was talking to Dr. Manu. He was, we were discussing about one term called as upavasa. You know what is upavasa? It's not English word for fasting. It's about eating right things at the right time at right intervals. So we often, now I think Ritesh and his team have, put me in such a spot that, I should not break that upavasa. It means you eat right food at right time. So they've exactly given me half an hour so that we don't exceed that half an hour spot. And now, all of you, whatever models you develop and whatever studies you conduct and whatever papers you publish is ultimately has to be consumed by the industry and the end users. So this panel, what I have today is picked up from the end users of whatever research you carry out. So I have people from the medical fraternity, I have people from the supply chain, I have people from the defense as well, who cater to the defense sector. I have Dr. Praveen Shastri. Dr. Praveen Shastri is a distinguished radiologist and a healthcare leader with an extensive academic and professional portfolio. And and he's holding multiple degrees, and some of the full forms I don't know either. MD in MD, DNB, EDIR, DICR, MNA, MS, and MBA in healthcare. And he's renowned for his expertise in radiology and healthcare management. And he's one person who actually is a part of one big group called as 5C network, who actually use the neural networks and deep learning models for radio diagnosis and practically use it for giving your reports. And the models they have trained has used terabytes of data and lakhs of samples. So you imagine the precision of the models that they have developed. And I'm also proud to say that he's my PhD student as well now. Okay. Next, I have Dr. Manu Sudhi. Dr. Manu Sudhi is a combination of Ayurveda and allopathy medicine. He's a BA MS in Ayurveda and MBBS and MD. So he's a combination of allopathy and he's a combination of Ayurveda. He brings in best of both the sides, and he's also doing PhD. He's planning how to treat patients using non-invasive diagnosis methods, and he's also pursuing PhD in MIT. And once again, I'm proud that he's my student as well. And I have Mr. Mayur Shetty, and Mayur Shetty is our own alumni. And Mayur is a founder and CEO of Black Frog Technologies. He's the alumni of Manipal, and so under his leadership, the company has developed, I'll have to do it. Under his leadership, the company has developed, patented technologies for the secure last mile delivery of temperature sensitive vaccines. During COVID times, we felt the need for that. Earning over 11 national awards and international acclaim, his Black Frog solutions have developed, are deployed at around 14 plus Indian states, ensuring safe delivery of over 2 lakh doses of critical vaccines in both rural and remote areas. And now he's focusing in African continent as well. And he has a fellowship at Cambridge University, George Business School, which was sponsored by BIRAC, Government of India. So currently he leads the Black Frog initiatives in developing an end-to-end vaccine traceability system and a digital platform to enhance immunization and process efficiency. So my dear friends, we have a panel which has, and I've been discussing with my friend since long and I forgot about him only. I have our own Vijay Shantagiri. He's a person, he's the CEO of Analogica and Certissured, the two innovative ventures. One tries to give placements to the technical graduates and postgraduates. Another caters to the defense systems and so on. So we have people from the supply chain, Mayur, we have from radiology, Dr. Shastri, we have Dr. Manu, who is from the emergency medicine, and we have from the defense domain, Dr. Vijay. So we have people, practitioners almost from all areas. Now, with this brief introduction, I welcome them and you as well for the panel discussion. So, friends, I think the word artificial intelligence was first coined in 1956 in a Dartmouth Summer School Research Project conference, like similar project, maybe conference in 1956. Since then, it has now just not been a keyword or a buzzword, but it is in action today, and more into action because of the generative AI. I think my friend before spoke about many of those parts. So, we'll start our panel discussion with this brief introduction to the topic as well as our resource persons. Now, my first question would go to Praveen. Dr. Praveen, now how has AI transformed your approach to radiology diagnostics as such?
Very good afternoon, everyone. I would like to thank the organizing team of IEEE and Dr. Shetty sir for having me over here. So I'd just like to give you all a perspective as to what a radiologist does. So, and thereafter going to the implication of how AI has transformed how we work. So in medicine, AI has done, like, there's a lot of scope for AI to work around. But in radiology, it's a low-hanging fruit for the reason that we have structured data. For every stack of images, we have a report to train the models. That having been said, as a radiologist, we actually procure images, interpret it, and generate a report which is very source of communication with the referring consultant. So AI has been extremely supportive at every step, may it be image procuring. So it has actually standardized image procuring. And there are a lot of challenges. I'll not get into the the deeper aspects of it, but we can actually procure images. We are multi-centric. We are pan-India presence with more than 100 centers. So maintaining standards and procuring the right set of sequences for a given case is very instrumental to help the patient and to get the right diagnosis. So by deploying AI, helping a simple LLM model which says what sequences have to be taken in a given condition has phenomenally helped standardize the entire image acquisition process. Thereafter, we have built routing processes wherein the most qualified radiologist would actually, the case would end up with that person rather than somebody else. Say a neuroradiologist would get a brain case. A MSK or a musculoskeletal radiologist would actually be reporting a knee or a shoulder case. So this routing system has also made sure that the efficiency has increased multifold. Next, we have multiple computer vision models. Earlier, we were mainly working on CNNs. Thereafter, we have resorted to vision transformers and now VLMs. So we've built multiple models which have great accuracy, somewhere upwards of 90% accuracy in image detection. And to wrap things up, we have again large language models which can generate reports. So by deploying AI at every single step, we have actually seen firsthand that the duration or the turnaround time has been reduced approximately, like a study has been done wherein 42% reduction in turnaround time has done. So that has impacted hundreds of lives and we are just beginning. Very excited to see how this manifests in days to come.
Thank you, Doctor. I'll move on to Dr. Sudhi now. Dr. Manu, you come from the emergency medicine department, which is a time-sensitive thing in the sense you'll have to take action immediately. How has AI helped your domain as such?
Good afternoon, everyone. Thank you, sir, for that great question. I'm from emergency medicine. To give you a basic workflow in the emergency department, so we see multiple sick patients at one point of time. So I'll be dealing with 5 to 6 patients who are sick at a single point of time. So the initial step in the management is generating differentials. So they'll give us symptoms, what are they suffering from. So what all could this be? What could be the most probable diagnosis? So when we are seeing multiple patients at a time, it is possible that we might miss on one differential. So if we have an AI model which is giving us all the probable diagnosis and suggesting us what investigations to send, we don't miss out on that. So that would be the first step. The next would be actually making the diagnosis. That is where we would look at the lab data, then we would look at the images, X-rays, CT, MRIs, ultrasound images. So again, there are a lot of AI models which are giving us the diagnosis. Say when we're looking at CTs and MRIs, sir is a radiologist. So we will be able to interpret CT and MRIs at a very basic level. Otherwise, we'd have to approach a radiologist for the same. So if the radiologist is not available and we have a well-trained AI model which can give us the diagnosis, it can go a long way in making that diagnosis and that patient getting that treatment, especially in strokes where the treatment has to be started within 4 hours and the patient has come after 3.5 hours. Now we are not going to wait for the report to come and then start treatment. So that is somewhere where we would use. The next step is administering treatment. Again, AI models have shown that it can predict what will be the most effective treatment. Giving a very simple example, some patients do respond very well to one analgesic or a particular type of antibiotic. So again, making that decision becomes easier for us. And the last one would be disposition. So talked about it in turnaround time. So we have a lot of inflow of patients. We need to quickly manage them, stabilize them, and then shift maybe a discharge, it may be admission to a high dependency unit or an intensive care unit. So again, helping us in those decision making processes is what we are looking at. We are a new specialty in the medical fraternity, emergency medicine as such. So we are looking at all possibilities where AI can help us in this process.
Thank you, doctor. Now moving on to Mayur. Mayur, earlier when I used to search Google for cold supply chain, everything spoke about canned food and ice creams. But today even vaccine also need a cold supply chain. Can you give me an overview as how AI is making noise in your field and how are you using it?
Thank you, Professor. Maybe I'll give a quick context to the kind of work we do. We run a medical refrigeration company. We help in transport of thermally sensitive biologicals like blood, culture, serum, sputum, vaccines, anything that require temperature control essentially. But vaccines are our focus because ever since COVID, now the entire global health focus has gone toward future epidemic preparedness. We don't want the next epidemic to be as bad as COVID. There's also a lot of significant investment in malaria and dengue vaccines now, not just routine vaccines in India. So we help with the last mile delivery. We developed a portable battery powered system, so you're able to carry these biologicals to very rural and remote communities. And essentially, end of the day, it's a refrigerator, right? So Industry 4.0 kind of forced us into having an IoT system in it. That was the first step, where we were monitoring temperature, location, where is the asset going, who is getting immunized, who is being left out. So that was the first step of what we were doing back in 2022. Right now, we've taken it one step ahead because we're able to leverage existing AI tools to kind of incorporate other hardware existing technologies like barcode scanners, QR code scanners at the point of delivery. So essentially what we're trying to solve is the unfortunate situation in India is that the shoes we get on Amazon today, they have more traceability than the vaccines we receive. So that's essentially what we want to solve. So every time a pregnant mother or a infant is getting a vaccine, we scan the vaccine vials and we correlate it against the patient ID card so that there is traceability of who got which vaccine from which batch, which lot, which manufacturer. That backward traceability is what we built. This will ensure that you're never at risk of getting like a hepatitis A vaccine instead of hepatitis B vaccine, a recalled vaccine, expired vaccine, counterfeit vaccine, lot of challenges in the supply chain today. All of these can be curbed at the point of administering. So now with AI tools, we are able to build this inventory management system. So there's a saying in the vaccine supply chain that you have to store just the right amount at the right time. The primary health centers that store the vaccines, if you understore, you're obviously not vaccinating enough people. But if you overstore, the challenge is it always goes to waste. There's power failure, there's human error, lot of reasons that the inventory goes bad. So having that right inventory has been a challenge, and that's something that we've been able to solve now because you have this data of how many doses are going out, how many are being administered, how many are coming back. So you're able to plan your supply chain better, inform value chain decisions. That's one end of things. I think the more obvious or the interesting bit as an engineer is probably on the predictive service part of things. End of the day, it's a hardware product. It's going into the field. It's going to break down. So we want to know when will it break down, what is going to break down. Is the fan going to turn off first, the battery voltage going to go off? So I think that's very critical in healthcare because you can't have technology dropping the ball. I mean, even from a COVID standpoint, the scientists have done an incredible job, right? And within a year's time, we had the vaccines. The doctors and the frontline workers are all doing an incredible job. It's the engineers. We've failed. About 65% of vaccines go to waste today because of poor cold chain. That's not a health problem. That's a technological challenge. That's what we wanted to get at the forefront of to ensure that if something is going to break, if a refrigerator is going to break down, we know ahead of time. Like just to end with an example, the corneal tissues that get transported. So in India, we have a huge challenge of donation, right, for eyes. And in cities like Mumbai, close to 75% of donated eyes go to waste. And India's average is 50%. 50% of all donated eyes go to waste. And it's terrible because you have to tell somebody that please donate your eyes, but then there is a 1 in 2 chance that we will discard it because of poor temperature or how we maintain it. So it's imperative that we know that our equipment is 100% at all times, and if there is going to be a breakdown, we know ahead of time so that we can figure out an alternative. So I think that's what AI is helping us with better decision making, so that we're able to bring quality. And that's a challenge in India, right? We're very proud that we've delivered 1.2 billion doses of vaccines, but how many of them are that effective, right? I think AI is going to be instrumental in ensuring that we don't just talk about numbers, we don't just talk about quantity, but the quality of our healthcare delivery improves.
Thank you, Mayor. Dr. Vijay, when this Ukraine war started, we also was bothered about the humanitarian crisis.
Okay.
But we were also observing drones, we were also observing, how, humans are being replaced mainly by the machinery. So, from you being a person who is supplied to the defense field, can you give us an overview about your work as what you do? Yeah.
So thank you very much for having me here. I actually finished my MTech in Astronomy and Space Engineering here in MIT. And after that I went to work with the defense, and then now I'm in AI, catering to defense problems using AI. So you brought up the right topic about Ukraine. When Ukraine happened, and anybody would understand that Ukraine being a smaller country and Russia being the real big machine. So, but still, the winds, everything favored Ukraine because of a term called asymmetric warfare. Okay, it means what? It means you have a very big warship which costs crazy, and then you have a very small unit, a drone, which can carry a specific kind of bomb, and it is going to just be placed in the exact position where it's going to impact or maximize the damage. So what happened here? A very big asset got neutralized by a very small investment. So this is the asymmetricity of the warfare, right? Now what we do is, sometimes we are called because of my background because I'm being specific about why I'm being called for them. Otherwise there are many people who can do it. But why my skills are needed there is, one is because I understand AI, then I understand the spatial temporal information system, because space-time objects, right? Missile is a space-time object. So in generic, if you see mathematically, if you see, it's a space-time object. How do you collect that data? What the physics? Now, then you have to now understand that some things are governed by actual physics equations, but some things are random, as both of them were talking about, Dr. Das and Dr. Richa Sharma were talking about the same thing, that so many things actually is undecided, uncertain, right? So now you have to model that. So all these things get modeled, that's where we go, and we simulate for them to know whether their asset can be neutralized by how many drones. Or if there are 100 drones, can you track those 100 drones, right? So I wouldn't like to say much because it's all sensitive. You record and send it, then I lose my project. So I don't want to say much. There's another aspect which is more interesting, where we have an EdTech as well called CertiSure, and the name says certified for sure. That's CertiSure. Okay.
Because I was asking how do I pronounce it,
So then how do we use AI to give value to this name? Because what does it mean when I say certified for sure? Somebody comes to me to get certified, the person has to go through series of assessments. Now if I employ one person to completely assess everybody time and again, the cost of the course increases because there is human involvement everywhere. So if I use AI to generate a lot of assignments and then let the person undergo, then monitor just the number that the person is getting. So I don't think I have already employed AI to personalize a training for somebody to bring them from a certain stage to a next level, which then is suitable for the industry. So we are trying to build that, and it's one of the very good things that is happening, and we are collaborating with many universities to bring the systems with them. So yeah, that's what we do. There's another question.
Thank you. Today morning when Dr. Rana was addressing us, he came up with, people talking to robots and robots replacing people and there's a great job loss. Recently, I'm one of the quality auditors, and I had been to one of the largest toothpaste manufacturing and filling factories. So where I saw that, the toothpaste filling is automated, the tube manufacturing is automated, even packaging is automated, even that large strip what you put on the carton, that is automated. Only the driver of the trucks, is what is a human being, and the people who oversee the factory, they are human beings. So I don't know where we will stop. Now, when Dr. Manu was talking, he said that if there is a critical situation, I don't need a radiologist to take decision, and I can get a quick overview of the radiology document reading. Doctor, what's your take? Will the radiologists be replaced, or will they be helping, or how is it going to go?
So to this, I'd actually want to counter saying radiologists can actually never be replaced. No matter how many times, let's say there are 100 instances, none of the solutions are 100% right. It's not 100% correct right now. Even if there is 98%, those 2% chances, if that leads to a loss of life or morbidity, who has to take blame? Is it the developer? Is it the company that sponsored them? Is it the hospital or the patient who opted that over a radiologist? So I'll just take a minute to tell you a story. Apparently, just like how we have self-driven cars, there is a story that says we had self-driven aircrafts. So when it was all ready to take off, the very team that built the self-driven aircrafts were asked, would you trust your machine over a manned aircraft for you and your family? All of them, I repeat, all of them said they would rather prefer a manned aircraft. And healthcare is no different. So when it comes to life or death, it would always be a doctor who's been trained over years for decades. And there are a lot of issues around. When there is, let's say, something around cancer. How would the feeling be if we get to know it through AI or an experienced doctor? There are a lot of areas wherein doctors are irreplaceable, not at least for our generation. That's my take.
Thank you. This story was told as a joke by my teacher. He said that, once an aeronautical teacher designed a helicopter, and the teachers who taught the student were asked to board the helicopter, and none of the teachers were ready to board the helicopter because they knew their students. But one teacher who took the class for 3 years, continuous years, sat inside the helicopter. Then others three were shocked. How did you sit? No, I know them. It will not fly. Okay. It won't take off, Pauline. It would not take off. Anyway, thank you, sir. Now, coming back to Dr. Vijay, how will it revolutionize defense as such? Will we reduce the number of soldiers, or how will the defense industry change because of AI?
I would like to say how I would like it to change, because I can't know how it will change, but I would say less war. I mean, more AI, everyone's capacity increases, and everybody knows you make one mistake, the effect will be really, dangerous. So eventually you will end up with world peace. And first of all, why do you have wars? Because of resource mismanagement. Correct. So once you have everything, AI, with supply chain and medical and everywhere, then obviously I think everywhere the war is going to come down, and that's what I would say. But to make a country stronger in terms of its defense capability, there are so many things which are already being put in place, and the most important thing is something related to data mining, where you flag an event. So now the LLMs come into the picture, where everybody is basically data are of text and numbers, so everybody is either collecting quantitative or qualitative data. Eventually LLMs take a decision on it. So there are situations where every day reportings are being done everywhere in terms of text, image, audio. They're even listening, they're seeing, all in terms of like how you detect in radiology a certain event. Like that, there are certain events that should not be happening, so you will use that image to detect them using drones. So this is the most important area, and you will not lose jobs here because these are very critical. You can't simply trust the machine to take the decisions like this. So it's just augmented. I mean, eventually the decision will be taken by the generals with a lot of experience.
Okay. I agree with him that wars should not take place, but economists would not agree. They want elections and wars continuously because this generates employment and money flow in the market. One election, we are talking about, it will actually reduce the money flow. Many elections are good sometimes. Anyway, coming back to Mayur. Mayur, you said, engineers, it's a failure of the engineers, maybe not because of the medical fraternity that led to so much of loss of vaccines or loss of organs during the transport. What challenges would you like to throw open to the engineering fraternity who are watching us or maybe who are present here to come up with new solutions or come write papers or do research on that?
Yeah, I think health is a great space. I mean, specifically from an MIT standpoint, I think we operate in a lot of silos here, right? MIT does not know what KMC is up to, and KMC does not know what's happening here, which is a huge opportunity, I think. I mean, to kind of stress on what Sir said earlier, I don't think there is any reason for apprehension at large. I'm not a big believer in Terminator end of the world scenario because of AI. I think we should have a healthy respect, and I think adoption should happen. Also, from a even if it's from a standpoint of global crisis, right? I think we should look at it the same way that we looked at nuclear weapons at some point, right? It didn't lead to the destruction of the world as everybody envisioned. Actually, nuclear weapons are the reason that there aren't that many wars today, right? Everybody's too scared of the nuclear option, so it's keeping things at peace. And I think the same thing applies to AI as well. I think we're at that. India is a unique challenge. If I had to come back to healthcare on students and engineers leveraging AI, because I think government of India is a little apprehensive. Generally, we are not very keen. I mean, we've not been keen on drones either, right? I think if we took a step back, the drone revolution happened in 21-22. And when we when we wanted to transport vaccines in Northeast India, we wanted to mount our systems, retrofit it onto drones so that they can get into these remote areas in Arunachal Pradesh. One of the challenges of letting private companies, startup companies to get into the space was, and the DPIIT secretary actually told me this, he's like, Mayur, like, what if like somebody sticks a plastic explosive on a drone and flies it into the parliament? Right? So that's a fundamental worry that we have, and from a health standpoint, India does an incredible job when it comes to public health, right? We have a huge machinery, and this starts with point of care devices or any digital tools and goes all the way up to AI, where there is a little bit of apprehension. So I would say that smaller solutions or startup companies that want to do this, and this is a model we took up as well. Smaller island nations, smaller nations in the African continent, much easier to pilot. They're a lot more responsive to newer technologies. The regulatory pathway is much easier to navigate. So I think, and that's not very well known, right? Like what we want is, if I will build a solution, does it work in my house first, right? Before I take it out. And that might not be the case. Like, I could be an incredible chef. I make the best butter chicken. But if my family does not eat meat, it's going to dishearten me. So I think it's important for engineering, especially MIT students, to look outside of their own realm of things, specifically network with more of your peers from the healthcare side of things, and I think that'll open up a lot more problems and then subsequently solutions.
Thank you, Mayur. So he speaks about networking. Okay. Now I'll go back to Manu. Manu, you see the patients directly, and once patients come to you, then the reports, you ask their reports. Now, do you think, as doctor said, that they would not be ready to accept technology directly? But how do you see, if you talk about robotic surgery or if you talk about machine-generated reports, are the patients ready for it?
So before I go into that, I just want to clarify that regarding radiology, what I meant was...
No, we know. I was in a lighter way, don't worry. I put it in a fix.
I was talking about centers which don't have access to radiologists, not our center where they are available. So the question is, there is a lot of talk going around. See, if you just look around, there are a lot of apps which, if you give your symptoms, will give you a probable diagnosis. It can suggest treatment. Then what is the need of a doctor? So there's a lot of talk going on around that. So I can talk about my specialty, emergency medicine. I talk to you about how many critical decisions has to be made over my shift, say probably 7 to 8 hours. So by the end of the shift, there is definitely a decision fatigue that sets in because of all the critical decisions you take. So AI in that sense can help us a lot in our day-to-day practice, giving us differentials, suggesting investigations, all that. So that decision fatigue can be definitely reduced, and it can make life easier for us. But there are a lot of skill-based things that we do. Every doctor for that matter. It might be procedures, minor procedures, major procedures. So AI is not in a position to take over that. Even when we are talking about robotic surgeries, it's always that robot is manned by a surgeon. It is not completely automated that you have a problem, you're on the table, and the robot takes over completely. There is always a surgeon who's keeping a check on it. So that, I think at this point or in very near future, we are not in a position where AI or robots can completely take over. That would be my take.
Thank you, Manu. So it's 1 now, and I'll try to conclude. I'll ask each one of the panelists to conclude. You also please state the challenges that you face in your respective domains while you conclude. Over for concluding the statement, Dr. Vijay.
So let me conclude. First, let me talk about the challenges that we have, especially when it comes to defense. Of course, the tech is easy. LLMs have made our life very easy, so there's no challenge there. Especially with defense, I'm actually appreciative of the work of the doctors here that they've actually implemented it successfully. Most of the imaginations that we have in defense, only half implemented, 75%, it won't actually give the result. Okay, because the kind of expectations that we have from it, it doesn't happen. Why? Because we are not everywhere. The kind of sensing devices that we have, as Dr. Das was saying, the noise in the measurement, that we are not able to get that perfect measure in, to store it properly and then use it. So that noisy nature of that feedback that we get is always an issue, and that is not an AI problem, that is an engineering problem and semiconductor problem, how good your sensing devices are. So once we get that in properly, I think all the math is in place. So then to conclude, I always wanted to say this, and what I wanted to say is when it comes to the anxiety of AI taking over the world and everything, the gist of it is, you have to compare AI with humans. Humans work because of fear and love. Okay, either you are afraid of something or you love something. But there is no way you can mathematically input the idea of fear and love into an algorithm. Right? So there is no way you can actually one day get up and say that Jarvis kind of a being or a vision kind of a being is around taking decisions. It cannot happen. I mean, if there is somebody who wants to argue on that, maybe they can talk to me, but I've thought enough about it because I grew up watching Star Trek, where there was space and then there was a robot called Data. Right? My entire life has been about this. So anyways, so that's what my take on it is. So
I'll get back to that. Both of my
Yeah, thank you, sir. I think I'll just maybe quickly talk about what I think is a little bit of something to worry about. And I spend all of my day just constantly saying vaccines kharab ho rahe hai, vaccines kharab ho rahe hai. So please give me the privilege to be a little informal about this since I'm in my alma mater. I think specifically with using AI on an everyday basis, that I think one of the things we commonly do, and I advise my staff not to do this, but sometimes I do. A simple thing like I got my blood test done, a blood panel done a couple of weeks ago, just enzyme test for liver and pancreas. And when you get the report, you usually have this column that says this is the particular range that is acceptable for you, right? And I want to know a little more than that. I want to know what is the median and where do I really fit into this? Some things that I'm risk at. Am I really at risk? I want to just verify it. So the first thing I'll do is I'll open up ChatGPT, I'll upload it, and I'll get the analysis on that, right? And that's kind of concerning because I'm not just giving my personal data. It's my name, my date of birth, my blood group, my entirety of blood panel, my IP address. Everything is just like going into a larger system, which is a little scary. But it goes slightly beyond that. I think the challenge is also that we don't just stop it. Like and this is a regular advisory we have in the company. If you want to kind of polish your email, it's okay, use ChatGPT. But then if you're please do not upload anything confidential, right? That's something that we repeatedly keep saying. But then I realized I was speaking to one of my college friends. She works at an MNC, and I think something we do is we have this WhatsApp battle with people, with especially professional peers, right? And you don't want to sound so harsh about things. So generally, people upload it on ChatGPT and then get a revised version, and then you send. So we were just laughing about something because she sent me a message where it started with, "Here's the revised and polished version of your message," which was nice. It was funny at that moment, but then it got me thinking that we are letting these systems build very particular and detailed profiles of each of us. It started with my location, IP address, my blood group, and my blood panel, but now my personality traits, what do I like, what irks me, everything is being put into these profiles, which I think is a little scary. Rather than this dystopian Terminator scenario, I think it's scary that a pharma company knows exactly who I am, more than my hospital and my hospital records do. I've spent 30 years in Manipal, and my KMC's record is about this fat, and I don't think it comes close to what LLMs have on me today. I think that's a little scary. That's my closing notes.
Thank you, Mayur. I think they use your data. About love and affection, the person who spoke about time management in the morning, he showed me a lady bot. If he gets frustrated in the evening, he talks to her. It shows all the love and affection to him. Moving on to Doctor. Doctor, the challenges that you face and some ethical considerations, I think both of them have raised that. I think you can touch upon that as well.
Definitely, sir. So data privacy, building these models, we have a lot of challenges, wherein we do not have strict guidelines when we go about building these models. We have to anonymize the data, multi-step anonymization. So we don't have a proper AI framework as of yet in our country. So that is something we have to look up to. And then coming to the ethical considerations, when things go wrong, we do not know whom to blame. So, and to conclude, I'd like to emphasize on this part. We'll have to worry about who the end user is when we are building a solution, being a part of multiple things. So the end user matters. So speaking about radiology, there are tools which are radiologist replacement tools. There are radiologist triage tools and radiologist augmentation tools. So radiology replacement tools are not for RADs per se. It's for the other doctors or the general public. So what is it that we want to build? If we have a proper clarity on that, the outcome will really be impactful. That's my take on this.
Thank you, Doctor. Dr. Manu, your concluding remarks.
To conclude, while there is a lot of scope for AI in our daily practice and in future, where to a couple of areas where we would like to expand to, as a doctor who is in the bedside treating patients, there is always a healing touch, that personal touch which you give to your patients. So that is very important for a doctor-patient relationship. So again, we are in no position to replace that at this point. While we are all advocates for AI, I would always like to stick back to my basics of going and talking to the patient and then examining them, explaining to them what actually is the problem, and then treating them, giving that healing touch. So that would be my conclusion.
Thank you, Doctor.
Just to emphasize on the same thing, to suggest treatment is for AI, but to cure is always for a doctor.
So, friends, we had panelists from the diverse backgrounds talking to each one of you. Maybe during your lunch break, you can talk to them and ask questions. We are running out of time. Before they tell me to stop, I will stop it. So what we came to know today is AI is no longer theoretical. It has already started impacting us. Whether it will take away our jobs or not, we don't know. But it will surely have a positive impact if used in the right manner. European Union has brought AI laws. Even that law is not clear as to, it has only told that, talks about the human good and how it will impact the human being, but they have told that it is evolved over the years. Even as Doctor said, it's not concrete as such, what is right, what is wrong, what has to be done, what should not be done as such. And AI will surely have a positive impact. It will take the skill set from, like Dr. Shastri is trained in a very good, our own group KMC. So specialist doctors are in KMC, but what about the doctors who are not that specialized? So these AI tools maybe augment or help the doctors who are not that skilled to take better decisions. And Dr. Manu said, touch, doctor's touch. You might have felt during Corona when doctors were standing there and wearing a mask and talking to you about that, how you are feeling. No machine can replace that doctor's touch. And AI will surely help in the supply chain, maybe predictive analytics and so on. That's what we understood from Mayur. And we don't want wars, as Dr. Vijay said. AI may help us to reduce the number of wars so that they may act as deterrents. So these are the things what we came to know today. Thank you one and all. You are a great audience. And thank you so much, and thank you all the panelists. I thank all the organizers for giving us this opportunity. Thank you. Have a great day ahead and happy learning. Thank you.
Thank you, Dr. Shetty, and all the experts. Before you leave, we would like to thank you formally from our end. So I request Dr. Pavan to present a memento to Dr. Vijay. I'm sure you all enjoyed and had an enriching experience of this panel discussion. Thank you, Dr. Vijay. And I request Dr. Pavan to present a memento to Mayur Shetty. Thank you, Mayur, for coming here and spending your valuable time. He was our student and has always been very interactive. Every time he has responded to the call from MIT. Thank you so much. May I now request Dr. Princey to present a memento to Dr. Manusudhi. Thank you, Dr. Manu. And I request you to present a memento to Dr. Praveen as well. Dr. Praveen Shastri. Thank you, sir, for joining us here today. And I request Mr. Nitesh Naik to present a memento to the main person who has held this whole show together, Dr. Darshat Raj Shetty. Thank you for running us a wonderful panel discussion. Thank you so much. Dr. Shetty. Yes, we will have one photograph, please.
Look here. One second. Okay.
So, ladies and gentlemen, with this we come to the end of another session of ARIA 2024. As informed earlier through WhatsApp group, lunch has been arranged in Food Court 1, and we have arranged the transport to reach the food court. However, before we board the bus, you saw that we had many photo shoots here on stage, but we would also like to have a photo shoot with you all. Hence, our coordinators will direct you. We are going to have a photo shoot in front of the Academic Block 4, or what we call as the Innovation Center, or the glass building that you see in the campus. And after the photo shoot, we will board the bus, we will go to Food Court 1, we'll have the lunch, and post-lunch, as informed earlier, we are going to have the campus tour session. Please do participate. We will take you around Manipal. And in the evening, as informed earlier, again I am repeating, you are all invited to the gala dinner in the evening at the MAHE Beach Guest House. So please keep checking your WhatsApp groups for further information and instructions. We wish to provide you with the full Manipal experience. Thank you, one and all.